For 100 years, we drew the universe like islands scattered on a cosmic ocean. Galaxies over here, clusters over there, big blank nothing in between. It felt clean. It felt organized. It felt like we finally understood the neighborhood. We were wrong. Not a little wrong. Catastrophically wrong. The universe is not a quiet archipelago. It's a plumbing system, a network of rivers, gravity-sculpted flows that carry entire galaxies like leaves on a current toward monstrous drains we didn't know were there. You're not sitting still. You're surfing a current that stretches for hundreds of millions of light years, being pulled toward a darkness with no obvious address. Once you see the river, you can't unsee it. It explains why maps looked crooked, why numbers didn't balance, why everything you thought was stationary is really in motion. This is the story of the cosmic river we missed, and the day we admitted the map was lying. Open your mental atlas, find local group, Milky Way, Andromeda, Triangulum, neat, tidy, boxed. Now tear the box. The local group is not a box, it's a raft inside a far larger watershed, an immense supercluster-sized basin where gravity flows downhill along invisible ridgelines. We gave that basin a pretty name, Laniakea, immeasurable heaven, then promptly pretended it was just a label. It isn't a label, it's the shape of our fate. Boundaries aren't drawn by how bright something looks, but by which way it moves. Motion is the truth serum of the universe. When you follow the velocities, when you stop caring about photos and start caring about flow, you watch entire galaxies pivot like iron filings around magnets you can't point to. Suddenly the empty isn't empty, it's drainage. The bright isn't central, it's debris. And your home galaxy is not anchored, it's adrift. Start with the hardest question. Where is here? Your first answer is an address, solar system, Orion Arm, Milky Way, local group. That's a postal code. The physics version needs a different line. Which flow are you in? Because in deep time, where you are is where you're being taken. We are being taken. Us, Andromeda, the dwarfs, the satellites, the star streams, all of it, flowing along filaments of matter toward a gravitational basin we called Virgo, then beyond Virgo toward something worse, the thing we nicknamed the Great Attractor, because naming is easier than understanding. The Great Attractor is not a single monster you can photograph. It's the summed pull of a massive overdensity buried in dust, distance, and denial. If you could paint the universe in vectors instead of color, little arrows showing where everything is going, you'd see the arrows align like wind over a ridge, funneling us toward that dark valley. Your instinct is to ask for a picture. There is no picture. There is a field. Pictures lie. Fields don't. How did we miss a river big enough to carry 100,000 galaxies? Because we measured where things were, not where things are going. Telescopes are gossip machines. They show you surface stories, the lights, the shapes, the photogenic spirals posed for postcards. But gravity doesn't read postcards. Gravity moves mass. If you want to understand the landscape, you stop looking at snapshots and start tracking flows. Radial velocity, proper motion, peculiar motion relative to expansion. Subtract the universe's stretch, and what's left is the true shove, the local terrain pushing you downhill. When researchers did that, when they turned off the seduction of pretty pictures and plotted velocities in 3 dimensions, something terrifying crystallized. We live on a slope. The cosmic web isn't just a spider's ornament, thin threads on a glass pane. It's topography, ridges, saddles, basins. Filaments are ridgelines where matter stacks. Voids are bowls where it doesn't. And every bowl has an exit, every ridge a direction of fall, every watershed a mouth where everything drains. We drew coastlines and missed the rivers. Here's the part your intuition will fight. Galaxies don't need roads to stay organized. They need gradients. Imagine rolling a handful of ball bearings across a warped steel sheet. You don't see the warp. You only see the bearings creeping together, accelerating here, pausing there, refusing to cross lines they can't name. If you're obsessed with the bearings, you'll invent forces that don't exist, mystical attractions, special friendships between particular beads. If you're obsessed with the sheet, you'll smile. Of course they move like that. The sheet tells them how. The universe is that sheet, a warped geometry made by matter, especially the invisible kind. The bearings are galaxies, filaments, clusters, your home. We argued about the bearings for a century. We finally measured the sheet. Once you do, the messy sky becomes a flowchart. You are a node on a river map, and the river never stops. Rivers have names. Some are famous. Virgo, Hydra Centaurus, Shapley. Emptiness has names too. Boots Void, Sculptor Void. Vast basins where nothing accumulates because there is no downhill to carry it there. Between them stretch the filaments, traffic lanes for galaxies. Think of them as interstates built by gravity itself. No asphalt, just inevitability. On those lanes, the local group isn't choosing a direction any more than a raindrop chooses which canyon to descend. Choice is a word life uses to make physics sound romantic. There is no choice. There is the gradient. You don't swim the cosmic web, the web carries you. What does a river feel like when you are inside it? Familiar. Ordinary. Motion at these scales is molasses for human senses. Millions of years for a subtle change in sky texture, billions for a cluster to grow teeth. But numbers can anesthetize truth. Translate it. You are not in a still life. You are in a slow avalanche, a long slosh toward teal. Deeper wells. Every night the constellations pose like they'll freeze forever. They won't. The Fisher King of Gravity is patient. He measures in eons and eats in bites. And today, you are halfway between bites. We should have known because the old picture kept breaking. Distances that disagreed. Redshifts that bent around dust you couldn't see. Clusters that held together with less visible matter than the math required. Dark matter, we said, the two words scientists use when they want to stop apologizing for being surprised. We were right about the invisible mass. We were wrong about how to map with it. We tried to glue galaxies into static superclusters, like butterflies pinned to cork. The pins were the error. Clusters aren't trophies, they're traffic circles. They look crowded because rivers converge there. They won't look like that forever. Rivers keep going. If motion is king, boundaries aren't fences. They're watersheds. Where does a supercluster end? Where flows diverge? Where a galaxy stops being pulled primarily toward one basin and starts drifting toward another. That's not a line you can draw with a marker. It's a contour you can only trace with thousands of velocity arrows and a generous tolerance for being wrong on the first 3 passes. We traced it. We redrew here. We discovered that our loyalties are not to the bright knot called Virgo, but to a deeper gradient that guides Virgo itself. Farther, darker, heavier, a basin so massive that even Virgo's pride folds into it like a creek into a river, like a river into the sea. Sea feels wrong because seas are flat. This end is anything but flat. The Great Attractor is a name we give to a directional fact we can't localize. It's not a lighthouse, it's a valley mouth. But humans build stories around nouns, not gradients, so we speak of it like a lair. Fine, call it a lair. What matters is that your home galaxy isn't circling a drain of its own choosing. It's being carried by the entire sheet tilting that way. Every nearby flow line falls with you. And if you zoom out farther, you see another tilt, deeper still, the Shapley concentration where the sheet dives again. We used to say, the universe looks the same everywhere if you stand far enough away. That was comfort, not truth. The universe looks smoother far away. It does not behave the same everywhere. Gradients rule, and they stack. So what does this change? Start with humility. Every distance you memorized is an artifact of the moment you measured it. Everything at rest is a perspective trick. We used to buffer that embarrassment by dropping phrases like co-moving coordinates, a mathematically polite way to freeze the river by drifting with it. That's useful for equations. It's useless for your intuition. In co-moving space, the river stops. In real space, it slams. If you want to know who you are cosmically, use the frame where the river is obvious. Identity is not where your house is. Identity is which way your house is going when the dirt under it isn't flat. You will ask for consequences. Start with the map in your head of nearby. Nearby isn't a radius, it's a branch. Neighbors are the galaxies attached to your filament, even if a brighter stranger glows the same distance away off your ridge. Trade your ruler for a watershed diagram. A dim companion lying along your flow may matter more to your future than a luminous showboat across the drainage divide. Astronomers chasing the brightest objects in the sky were like hikers choosing destinations by which peak looks shinier at noon. Wrong metric. Pick the peak connected to your ridge. Star formation, too, is not evenly salted across the sky. It's a weather pattern riding these ridgelines, a storm track where gas streams along filaments and collides in clusters. Filaments feed clusters like rivers feed deltas. Cut the river, the delta starves. See the map in flow, not just light, and you predict where galaxies fatten and where they wither. Even our favorite apocalypse, the coming tango between the Milky Way and Andromeda, needs a new line in the program. That duet is part of a chorus. The timing and angle of our collision aren't just a two-body problem. They're choreographed by the filament we're embedded in and the basin we're falling toward. Change the slope, change the steps. The closer we get to the deeper valley, the more every local motion is perturbed by the background flow. We used to tell the story as a love song between rivals. It's more like a rafting accident on a large river. Two boats bump, not because one aimed wrong, but because the current narrowed and the gradient steepened. Your romance was written by the watershed. If you're waiting for the life part, what about us here, skin and breath and fear? It's this. We evolved to trust stillness. Our senses declare victory when the ground stops trembling. Our civilizations stamp coordinates, write deeds, draw borders. The river ruins those illusions. When you pan out, the meaning of home is not a dot. It's an arrow. If that frightens you, good. Fear is honesty. But it's also liberating. Arrows compose, flows add. There is no single correct here. There is only the direction your neighborhood shares with everything around it, and that solidarity is comforting. Even the most arrogant galaxy is just one more leaf. We missed the river because it was slow by human standards and obvious by the universe's. That combination is lethal. We ignore the slow. We mock the obvious. Then, a set of measurements walks in with receipts, velocities that won't average to zero, flow lines that don't care about the bright stuff, and our careful museum of still pictures melts into a time-lapse river. That's when humility does its best work. The map becomes a movie, the borders blur, the future sharpens. You want a metaphor that hurts? Think of ancient cartographers drawing dragons on oceans they hadn't sailed. "Here be monsters," was a confession, not a warning. We spent a century drawing dragonless space because we looked at the pretty islands and pretended the water was decorative. The monsters were always there. They just looked like math. They slouch in gradients. They dine slow. They don't roar. They pull. Now, the practical question: how do you live different after learning this? You can't feel the current at your feet, not in a human lifetime, but you can inherit a better story. Tell your children that the sky is not a ceiling, it's a flow. Teach them to love fields, not snapshots. Show them how to read a map that doesn't lie. Arrows, not borders. When they ask where we are, answer like a physicist and a poet at once. "We are here," you'll say, pointing not to a spot but along a line. "Here is the way we're going." If that sounds like surrender, look again. Understanding a river is power. The boat that knows the current gets home. The boat that pretends the water still gets flipped at the first bend. Science is the art of seeing the bend before you feel it. We put instruments on mountains and in orbit to measure drifts we can't taste, add and subtract the universe's expansion like accountants tallying a storm, and pull from those numbers a topographic map of fate. It's not prophecy. It's better. Prophecy demands worship. Maps demand attention. Here's the moment that will stick with you. One night you'll step outside and the stars will look the same, and for the first time, you'll refuse to believe them. You'll feel the invisible as a kind of quiet. You'll imagine vast slopes and the long fall and the boats ahead of you fading into the bend. That sensation is not despair. It's belonging. Rivers don't isolate the drops. Rivers connect them. We were wrong about the universe because we were right about the wrong question. We asked, what is near, when we should have asked, where do we flow? We asked, how big is that, when we should have asked, which basin feeds it? We asked for edges in a world that only has gradients. Now that you've seen the river, don't go back to postcards, don't go back to boxes, don't let anyone sell you a still universe for comfort. It's a lie. The motion is the mercy. Everything changes, but it changes together. And if you insist on an ending, here's the only one the river allows. There isn't one. Watersheds don't end, they merge. Basins fold into basins until even our best names fail. One day, the gradients we can measure will wash into deeper gradients we can't, and the flow lines that define our identity will be folded into larger stories with larger pulls. That isn't erasure, that's continuity. The river widens, the current steadies, you keep going. You asked where we are in motion. You asked what is true. Gravity writes in arrows. You asked how to live. Read the map that doesn't lie. How do you draw a river that's invisible to your eyes, glacial to your instincts, and bigger than language? You don't start with pictures. You start with motion. You start with the one number gravity respects. First, the cheat that fooled us for a century. In an expanding universe, everything is receding from everything else on large enough scales. That general recession, the Hubble flow, makes it look like the cosmos is politely exploding in all directions at once. If you just measure how fast a galaxy's light is stretched, its redshift, and call that the whole story, you miss the local drama. The Hubble flow is the elevator. Gravity is the shove in the hallway. Cosmography, the mapping of our real neighborhood, begins when you subtract the elevator and look for the shove. That subtraction is the heart of the craft. A galaxy has two speeds blended into one spectrum. One, the expansion speed shared by all distant things, and two, the peculiar velocity, the deviation caused by nearby mass pulling or pushing. Peculiar velocity is a terrible name for something so honest. It is the field whispering, downhill is this way. If you want to see the watershed, you chase that whisper across millions of light years. But how do you know the elevator speed to subtract? You measure distance without relying on redshift, build a ladder tall enough to touch the galaxy itself, then compute how much of its redshift is just expansion for that distance. What remains is the peculiarity, the flow. The distance ladder is not one tool, it's an orchestra. Close to home, you use parallax, geometry at its purest. Earth swings around the sun, a nearby star shifts against the far background, triangles do the rest. Farther out, parallax fades, and you recruit lighthouses whose wattage you trust, Cepheid variables with clock-like pulsations, type Ia supernovae with near-standard peak brightness, surface brightness fluctuations that turn a galaxy's graininess into a ruler. Spiral galaxies obey the Tully-Fisher relation, linking rotation speed to luminosity. Giant ellipticals sit on the fundamental plane, a geometric conspiracy between their size, surface brightness, and internal speed. Farther still, you steal tricks. Masers orbiting black holes with measurable geometry. Strong gravitational lenses with time delays turned into yardsticks. None of these are perfect. All of them are good enough when you have thousands. With a catalog of redshift-independent distances, you subtract the elevator, h0x distance, from the observed recessional speed, cz, and extract the peculiar velocity. You do this again and again until the sky is stippled with arrows. Each arrow is humble, one galaxy, one measured nudge, but together they form currents. That's when the algorithms walk in. Picture a foggy landscape where you only see the grass move. You'd infer hills and valleys from the swaying alone. Cosmographers do the same with velocity fields, using mathematical filters that prefer smooth, physically plausible flows over jittery noise. Where arrows converge, you mark a basin. Where they diverge, you mark a peak, or, more often, a void, a region that behaves like a gravitational repeller, because the surrounding mass pulls things away from it. The map that results is not a snapshot of brightness, it's a topographic chart of destiny. This is where words like Laniakea stop being poetry and start being coordinates. A supercluster boundary isn't a fence, it's a separatrix, a sheet in space where the flow flips allegiance. On one side, galaxies pour toward Virgo and beyond. On the other, they fall toward different basins. Imagine painting the whole volume with dye and letting it run. The colors would braid into filaments and slide along the same paths the arrows reveal. We didn't invent the rivers. We discovered we'd been floating in them, and finally learned to trace their banks. Now, a correction your intuition needs. Gravity both attracts and, in a different sense, pushes. Mass pulls. Everyone knows that. Emptiness misleads. Few appreciate that. A large, underdense region, a void, behaves like a hilltop in the potential landscape. Flows roll off its crown. That is why the nearest big void matters to you almost as much as the nearest big cluster. You live beside absence as much as you live beside presence. The local void to our cosmic north doesn't grab us. It releases everything around it, and that release shows up in the arrows as a drift away from the void's heart. When you combine the pull of overdensities, Virgo, Hydra Centaurus, Shapley, with the push of underdensities, local void and friends, your motion makes cruel, beautiful sense. You are being coaxed downhill and shooed off the hilltop at the same time. Zoom in another notch. The cosmic web, the thing you've seen as stylized blue threads on 1,000 posters, is more than a work of art. It is a classification scheme that the field itself enforces. Mathematicians index the local shape of the velocity or tidal field by how many principal directions are collapsing versus expanding. All three collapsing? That's a knot, a cluster core. Two collapsing and one expanding? That's a filament, a gravitational highway. One collapsing, two expanding? A sheet, the in-between. All three expanding? A void, evacuation in 3 dimensions. This taxonomy, knot, filament, sheet, void, is not arbitrary. It's what happens when you let gravity sculpt for 13.8 billion years. Where do you live in that taxonomy? On a sheet hugging a filament. The Milky Way and Andromeda sit in a laminated structure sometimes nicknamed the local sheet, a relatively thin slab of galaxies coasting together before angling down a filament toward deeper wells. That slab rides the edge of the local void like a raft skimming a whirlpool's lip. From inside a life, it feels like stillness. From the right frame, it's a glissade. And then there's the zone of avoidance, the belt of sky the Milky Way's own dust tried to hide from us, our galaxy's attempt at a privacy screen. Optical surveys struggled there. Radio waves and infrared light laughed and walked through. Peel back that band and entire districts of the flow map brighten. Nearby clusters, walls of galaxies, the very scaffolding around Hydra Centaurus that kept masquerading as a mystery. The great attractor never was a single monster. It was a low valley mouth, partly obscured by our front porch. The embarrassment wasn't that we didn't see it. The embarrassment was believing the postcard between the trees. So what changed once the flows were drawn? We learned to ask better questions. You don't ask, "Who are my neighbors?" with a ruler anymore. You ask it with a watershed map. Neighbors share futures, not distances. That dim galaxy sliding down the same filament matters more to your fate than the brilliant stranger across the divide. We also learned to tell better stories about star formation and death. Clusters are not just crowded city centers, they are deltas where filaments drain. Gas and dwarf galaxies stream along those ridges, feed the giants, light the fireworks, then the fireworks snuff out when the environment strips fresh fuel. If a spiral galaxy leaves its river, harassed, heated, strangled, it quells, reddens, and joins the dead. Words like quenching used to read like pathology reports. On the flow map, they are weather. Spin, too, got demystified. Galactic disks don't orient themselves by taste. They tend to align with their streets. Light halos and dwarfs often spin with axes along the filament. Heavier halos flip to spins perpendicular to it, a transition that shows up in simulations like a rite of passage. The river is tutoring angular momentum while it ferries mass. The cosmos has a traffic code, even the romance you know by heart. Milky Way meets Andromeda, 5 billion years, sparks and tidal tales, shrugs and makes more sense in a river frame. Their dance is not a duet, it is a collision scripted by the corridor they share and the gradient beneath it. You can calculate the angle of approach from the filament's spine. You can watch how the background flow tweaks their orbits, like a current nudging canoes toward the same boulder. If you must anthropomorphize it, call it fate. If you must quantify it, call it boundary conditions. Some of you want the instrumentation. Fine. Peculiar velocities require honesty about error bars. Distance indicators scatter, supernovae misbehave, dust lies. That's why you never trust a single galaxy's arrow to tell you the slope. You trust ensembles, smooth the field with methods that punish drama and reward coherence. Combine radio distances from 21-centimeter line widths with optical distances from standard candles. Cross-calibrate rungs of the ladder so the orchestra stays in tune. And always compare the flow-inferred basins with the mass you can estimate from light, stellar mass, from hot X-ray gas, cluster potentials, and from weak gravitational lensing, the field's fingerprint on background galaxies. When the arrows and the mass independently point at the same valley, that is cosmography's click, like hearing the lock turn under your hand. But dark energy, someone says, trying to rescue stillness. Yes, the universe's expansion is accelerating on the largest scales. No, that does not flatten your neighborhood. Dark energy is the faintest of breezes in the hallway compared to the shove of local gradients. It makes the elevator speed up. It does not repaint the floor you're sliding across. The river carries you just the same, though the sea beyond it may be expanding faster than you expect. Another objection. Isn't everything eventually washed smooth? In the asymptotic far future, structure growth slows, distant basins fall off your horizon, bound islands detach as the cosmic tide rises. That's a story for Part 10. For many tens of billions of years, flows still matter within the islands that survive. The watershed frame will remain the honest frame for anything you could ever call nearby. We also learned humility about coordinates. The cosmic microwave background, CMB, hands you a universal rest frame, a standard of no dipole against which you can measure your motion. Our local group screams across that frame at hundreds of kilometers per second, a truth that used to feel like trivia and now reads like a confession. Your whole town is surfing. When you transform to the CMB frame and the flow arrows stop tilting as much, you feel the difference between a good convenience and a good lie. Co-moving coordinates are a clever convenience. The no river picture is the lie. Let's talk about the thing that rattles philosophers and comforts engineers: predictability. Once you know the field, you can predict the flow. Not perfectly. Galaxies have their own small feuds and the map isn't complete, but statistically, robustly, usefully. You can forward integrate the arrows, watch filaments fatten, see clusters accrete, estimate how quickly a void will evacuate the last stubborn dwarfs clinging to its rind. The web is not a frozen lace. It is a living drainage network, and drainage networks have rules. They obey scaling relations, they branch with biases, they carve with memory. That is not determinism in the mystical sense, it's physics in the merciful sense. If you respect the slope, you can stop being surprised by the path. I can hear the human question again. What does this do to meaning? It doesn't delete meaning, it rescales it. Standing at a river's edge does not cheapen the poem you write about water. Knowing why your city was built where it was, on a bend, by a ford, above a floodplain, does not cheapen the cathedral. It deepens it. A civilization that knows its watershed respects the flood and invests in levees. A species that knows its cosmic watershed respects the gradient and invests in truth. The alternative is to build temples to stillness on sliding ground and call the cracks mystery. A practical payoff you can feel even from your backyard. Perspective. The night sky's brightest temptations, arcs of the Milky Way, the jitter of Orion, the smug triangle of summer, invite you to arrange your life around brightness. The flow map teaches you to arrange your questions around connection. Which dim smudges share our descent? Which invisible strands feed our cluster's appetite? Which voids carve our route by sheer lack of care? Teach a child that, and you have inoculated them against the prettiest lies. We haven't even used the best metaphor yet: Cartographers of rivers talk about capture, when one stream erodes its headwaters into the basin of another and steals its flow. The cosmic web does this with finesse. A filament fattens, a saddle thins, a once loyal tributary of one cluster is captured by a deeper nearby basin. The galaxies didn't change their minds, the landscape changed their options. When you look at a historical map of constellations from 1,000 years ago and a velocity map from today, you're seeing the same kind of capture drawn in two alphabets: myth and math. We should pause to honor the illusions that kept us slow. Still photographs of spiral arms, Hubble-deep fields full of infant galaxies, postcards of nebular candy. These seduced us into thinking in nouns. Nouns have their place, but the engine of understanding here is the verb: flow, drain, slide, merge, evacuate, quench, feed. If you let the verbs replace the nouns while you stare at the same images, a new layer of information pops out like a hidden stereogram. The bright knot is not a prize, it is a confluence. The dark lane is not an absence, it is a levee. The empty circle on the map is not neglect, it is the crown of a hill from which everything else is leaving. And yes, it changes the stakes of our favorite arguments. If you imagine the universe as a random sprinkling of lights, you can ridicule our motion as an accident of placement. If you accept the web, you see design without a designer, pattern born from gravity's simple rule compounded over time. You can trace that pattern from the tremble of the infant universe. Minute temperature ripples in the CMB, through the adolescent web of filaments, into the adult clusters belching X-ray heat, to the old red, elliptical cities that sit at every confluence like retired generals. You don't need to assign purpose to feel awe. You need to assign gradients to feel home. Let's end part 2, where your hands can touch the glass. If you could paint the sky tonight in peculiar velocity arrows instead of visible light, you'd see bias replacing beauty. Arrows would elongate along filaments, shrink across sheets, spray outward at void edges, and hush into the centers of clusters where orbital chaos replaces coherent fall. You would feel, maybe for the first time, the difference between crowding and converging. Crowding is a photograph, converging is a future. You cannot feel the river with your skin. You can learn to feel it with your map. That is what these measurements buy you, not comfort, not prophecy, but the dignity of alignment, your story's arrow pointing the same way as your galaxies. When you step outside and the stars refuse to confess their motion, forgive them. They are terrible eyewitnesses and excellent conspirators. Gravity writes its true testimony in the drift you cannot taste. You've seen the map and you've met the river. Now we hike the bank. This is a travelogue of birth, youth, crisis, and afterlife for galaxies riding a cosmic filament, a biography written in gravity's handwriting, no postcards, no museum glass. We walk with the current and watch what the river does to living light. Headwaters, where galaxies are born. Every river begins where cold water gathers. In the cosmos, those headwaters are cold streams of pristine gas threading the dark matter scaffolding like veins in a leaf. Picture narrow, translucent conduits, hundreds of thousands of light years wide, funneling hydrogen straight into small halos. There's no pomp here, no fireworks, just chemistry with good timing. Gas that stays cool can collapse. Collapse lights stars. Stars teach darkness to glow. Infant galaxies in these headwaters are messy, blue, and enthusiastic. Their disks are wet cement, lopsided, clumpy, easy to disturb. They breathe in cold gas, turn it into bright newborns, blow some of it back out with supernova winds, then swallow the fallback later like a child retasting a thought. Feedback isn't a moral, it's a thermostat. Too hot and you quench the fire, too cool and you smother under your own smoke. The headwaters strike a balance that lets stars appear by the billions without boiling off the future. Listen long enough and you'll hear another rhythm. Accretion, not just of gas but of companions. Dwarfs fall in, kiss the disk, leave ripples, tidal streams of old stars curving behind them like the contrails of migrating geese. That's the headwaters' signature, growth by sipping and nibbling, never yet by swallowing a pier whole. The river is gentle here, gravity whispers. Change is fast only in the language of eons. Adolescence in groups, pre-processing. Every river collects tributaries, filaments do too. Along their length you find knots of half a dozen to a few dozen galaxies bound together, loose associations with just enough gravity to host gossip and just enough time to let gossip matter. Astronomers call it pre-processing, which sounds bureaucratic for something so personal. Before a galaxy ever meets a great cluster, its temperament is already being edited by the company it keeps. In groups, orbits are slow, collisions aren't head-on, harassment happens by many. Small encounters that add up. Disks tilt, bars grow, gas sloshes. Two modest spirals can embrace, crush their ordered rotation into a star-bursting blur, and relax as a single more spheroidal system with scars you can still trace in shells and ripples. If a central galaxy lights a black hole, jets can heat the group's thin atmospheric gas and throttle future star formation across the neighborhood. That's power disproportionate to size, a mayor with a megaphone. Pre-processing also breeds a social hierarchy. Some dwarfs surrender their gas early and redden. Others, shielded by geometry and luck, keep forming stars until the last possible minute. There is no judge, only circumstances. A galaxy that would have stayed blue in splendid isolation can arrive at the cluster already tired, as if it smoked its years away with friends before ever meeting the city. The long road. Drift down the filament. Between groups stretch the quiet lanes, hundreds of millions of light years where nothing dramatic happens fast and everything consequential happens anyway. Galaxies drift, sip, and occasionally bump. Gas continues to stream along the filament's spine, faint but faithful, like groundwater feeding a river between storms. Some halos spin up, some flip their spins when torques from the larger web rearrange the carpentry under the floorboards. Angular momentum isn't a birthright, it's a negotiation. If you could overlay arrows on the scene, you'd see them align along the filament's length, like wind combing a field of tall grass in one direction. That alignment means your neighbors share your future, even if you barely know their names. A dim dwarf 2 towns away but downstream matters more to your fate than a bright giant just across the ridge in another basin. Neighbors in the river sense aren't the ones at your elbow. They're the ones in your current. Weather arrives, mergers of basins. Rivers flood when it rains. Filaments flood when basins collide. Sometimes 2 neighboring knots, groups or modest clusters, fall together along the same corridor and hammer their gas into X-ray hot sheets. Shock fronts race like invisible tsunamis. Star formation spikes in the victims with intact gas and dies in the ones whose tanks were already low. If the kings of each knot, the brightest central galaxies, survive the first pass, their eventual merger can sculpt something huge and round, a CD giant with a faint extended envelope like fog backlit by a winter street lamp. These are the storms of the web, brief compared to cosmic calm, decisive compared to human patience. The filament doesn't end, it fattens. The river doesn't change course, it cuts a deeper channel and carries more boats. The city wall, crossing the cluster's edge. Then the skyline rises. A cluster's virial radius, its real city wall, looms like an isobar on a weather map. Cross it, and the rules change. Outside, galaxies meander with the current. Inside, they orbit the metropolis. Outside, the gas between galaxies is thin and forgiving. Inside, the intercluster medium is a furnace, 10 million degrees and denser than polite company. The first thing you feel as you cross is wind. Not literal wind, there's no breeze to your skin, but the effective wind of hot plasma ramming your cold gas at hundreds of kilometers per second. This is ram pressure stripping, the river's harshest rite of passage. Gas that clung to your disk like dew is peeled away and hung behind you in a luminous tail. From far away, you look like a jellyfish, a blue-white head with a stream of star-forming knots trailing like tentacles. Up close, it's vandalism. Your nursery beds, molecular clouds that midwife stars for billions of years, are ripped up and thrown downstream. Not every galaxy is equally vulnerable. Big ones with deep potential wells keep some of their gas by sheer gravity. Dwarfs lose nearly everything in a single pass. The angle of attack matters too. Plunge face first and you'll be stripped to the bone. Skim the edge, and you might bleed slowly instead of all at once. The cluster is not cruel. It is consistent. Inside the walls. Harassment, strangulation, and starvation. Once your disk is thin on gas, subtler tortures take over. High-speed flybys, too quick for merging, jostle your stars and raise your velocity dispersion, puffing a once crisp spiral into a smoother, duller profile. That's harassment, a polite word for 1,000 little traumas. Meanwhile, your external gas supply, the slow drizzle from the filament, never makes it through the cluster's hot atmosphere. That's strangulation. You're not smothered, you're starved. The remaining reservoirs in your disk feed your last rounds of starbirth, then go quiet for lack of refills. Blue turns to green, then to red. You didn't fail. You were relocated. From the sidewalks of the cluster, you can tell the neighborhoods by color and texture. The core is dominated by red ellipticals and S-Virus, fat with old stars and little else. Spiral arms, where you find them, are anemic, faded like paint in sun. In the outskirts, nearer the wall, the mix is more diverse. You can still catch a blossoming spiral here, a remnant of the field, shouting color against the city's beige for a few orbits before the environment wins. City center, the brightest and the ghost light. Every metropolis breeds a civic palace, the brightest cluster galaxy, BCG, sitting near the bottom of the potential well like a boulder at the center of a whirlpool. It didn't grow there from nothing. It was assembled by history, countless minor mergers, a few major ones, and a rain of stripped stars from victims that ventured too close. Around it floats a faint sea called intercluster light, the orphaned stars ripped from their homes, now residents of nowhere in particular. At first glance, it looks like inefficiency. At second glance, it's the honest tax of living where gravity is strong. The river wastes nothing. It merely redistributes identity. Sometimes the BCG feeds quietly on cool gas that condenses from the cluster's hot halo. Sometimes a central black hole shouts, firing jets that carve cavities in the X-ray glow like footprints in snow. That feedback is an urban planning department with teeth. It can halt cooling flows that would otherwise build new stars, holding the core steady against collapse. The city is not dead. It is regulated. Afterlives, red sequence and fossil records. What happens to a galaxy after the cluster has had its say? Most join the red sequence, a family of passively evolving galaxies that trade fireworks for candlelight, red giants humming, old metal-rich stars running out the clock. They are not all the same. If you dissect their light, you can read their memoirs. A starburst here, a quenching event there, a long plateau of quiet afterward. Shells, ripples, kinematically decoupled cores, these are scars and tattoos, fossils of encounters now long cooled. Some galaxies refuse to go quietly. A spiraling intruder may carry in a last sip of cold gas and light a central flare, an active nucleus, a ring of newborns, a brief resurrection. But the city's climate is unforgiving. Unless you bring your own weather, you return to beige. The ones that get thrown back. Backsplash. Not every galaxy that looks like a city dweller lives there now. Some crossed the wall once, felt the wind, lost their gas, and got flung back out by orbital dynamics. These backsplash residents haunt the outskirts like veterans, red, quiet, and oddly shaped compared to true field spirals at the same radius. If you judge only by distance, you'll misclassify them as healthy countryside. If you judge by history, you see the stamp of the city all over their faces. The river's influence extends beyond the map's thick lines. Crime scenes, tails, arcs, and bridges. When cluster weather is violent, it leaves spectacular evidence. A jellyfish galaxy's tail can sparkle with newborn clusters, beads on a string, born in gas that should have been dispersed. Two middling galaxies on radial orbits can raise a tidal bridge of stars and gas between them that endures for 1 billion years, a fragile highway that nothing but gravity maintains. When two clusters slam together, the intracluster medium can lag behind their galaxies, separating mass peaks traced by lensing from X-ray peaks traced by hot gas. The headlines write themselves. Dark matter marches on. But the river's point is quieter. Different ingredients obey different rules. Stars and dark matter are collisionless. Gas is not. The city is a layered society. Lessons in spin and shape. Remember the traffic code. In the field and along filaments, disk spins often align with the street. In massive halos, orientation flips as mergers and torques rewrite the rules. That transition isn't just trivia, it's a social history. Disks that grew gently. Along the filament, keep their orientation like families that never moved house. Disks that got dragged through group mergers or cluster tides have the twisted, misaligned gas and warps you'd expect from a life of relocation. If you could listen to a galaxy's rotation as music, the headwaters would be a simple melody. The city would be a collage. Mass versus address, two ways to quench. Why do some galaxies stop forming stars even in the countryside? Because there are two routes to quiet. Mass quenching. Build a deep enough potential well and your central black hole heats or ejects gas. Your halo's virial shock keeps future inflow hot. You self-regulate into calm. Environmental quenching. Let the neighborhood steal your gas and prevent refills. Harassment and tides rearrange your structure. The climate does the rest. In practice, the two routes braid. A galaxy pre-processed in a group may bring its own black hole thermostat to the city. The city then locks in the choice. The river writes the setting. Mass writes the script. The show is a collaboration. Time as a character. Everything above sounds static because language fights duration. It isn't. Galaxy life along a filament is a time series with beats. Cold inflow era. Headwaters fizz with blue light. Disks assemble. Dwarfs rain in. Group era. Mild mergers, bars, secular evolution. The first central black holes clear their throats. Infall era. A few orbits in the cluster outskirts, first brushes with hot wind, tails appear, spins get nervous. Core era, gas stripped, harassment applied, color fades, structures puff, central black holes regulate from time to time. Fossil era, shells settle, intracluster light remembers, red sequence drifts gently toward darker red. You can stage an entire documentary with just those 5 chapters. The same galaxy as protagonist, the river as narrator, gravity as cinematographer. What fieldwork looks like. How do we know any of this without betting the story on a single instrument? Fieldwork is plural. Radio telescopes map neutral hydrogen being peeled away like silk, tails longer than the galaxy that birthed them. X-ray observatories see the city's atmosphere and the cavities pounded into it by black hole jets. Optical spectra age-date stars the way a botanist reads rings. Ultraviolet surveys catch the blue flare of newborns. Infrared maps dust warmed by their cradles. Weak lensing maps trace the dark scaffolding under the lights. Proper motion studies for the nearest groups give you orbits measured rather than guessed. Layer all that, and even stubborn skeptics start to nod. The river is not a metaphor you picked for poetry. It is the simplest picture that matches the evidence. A human-scale translation. If the last sections felt too large to touch, shrink the scene. Replace galaxy with city, group with county, cluster with continent-spanning megalopolis, and filament with trade route over navigable lea. Rivers. Headwaters are frontier towns where goods, gas, arrive unregulated, and entrepreneurs, star-forming regions, thrive. Groups are mid-sized markets where alliances form and small houses merge. The megalopolis has its own climate, its own rules, and its own taxes. It will make you rich in status, stellar mass, and poor in options, cold gas. After a century there, your factories shutter, your skyline glows with old windows, and your suburbs dissolve into a low glow of porch lights, intracluster light, civic ghosts. You didn't fail. You lived where the river took you, and the river is history with gravity doing the writing. The filament is not a fence. One danger of all maps is to mistake lines for walls. Filaments channel but don't imprison. A galaxy with the right kick can take a high-inclination orbit and nose across the spine into the sheet. A group approaching at an angle can skim the cluster and keep going, bruised but intact, feeding the city with breadcrumbs as it passes. The web is elastic. Rivers meander. Over long time, capture happens. One basin erodes its neighbor's headwaters and steals flow. Today's filament is tomorrow's wall. That's not contradiction. It's continuity. What it means to be home. By now, the sky you thought was still has a personality. The notion of home feels less like a pin on a map and more like a shared vector. Home is the set of galaxies that will cross the same ridgelines as you, feel the same winds, pay the same taxes to the same central wells. Home is the future you share, not the distance you measure. That shift in meaning pays off beyond poetry. It tells engineers which questions to ask, how hardware and software should be built to search for faint intracluster light or measure gas tails. It tells educators how to teach children to read maps with arrows. It tells philosophers how to ground humility in measurable motion rather than mood. The river writes, "You return to the headwaters at the close of the day and look downstream. You can't see the city from here. You can feel it. Cold gas hums with quiet purpose. Dwarfs snake along dark matter gutters toward meetings they don't know are scheduled. In the distance, group weather murmurs. Farther still, behind the curve of destiny, a cluster glows in X-rays like a hearth whose heat no newcomer can ignore. The whole thing functions without permission. It doesn't need you to believe in it to carry you. You were promised a travelogue and got a biography. That's because the river doesn't differentiate between place and time. A filament is a path and a plan, a channel and a chronology. That's the most useful heresy you can carry back to your daily life. Stop mistaking location for identity. In astrophysics and in everything else, direction is the part of where that tells the truth. One last scene. The crossing we all share. Stand with me at the city wall one more time, on the edge of a massive torrio. Cluster just outside the virial radius. You see newcomers arriving, head first or sideways, blue or already pale, trailed by tails like torn silk. You see veterans circling the center, red and round, rarely disturbed but occasionally flaring when a central engine feeds. You see orphaned light, intracluster starlight, pooling in the dark like the glow from 1,000 uninhabited windows. If you blur your eyes, the distinction between individuals and environment dissolves. There is only the web acting on itself, the river carving its bed to make more river. Everything in that scene is inevitable in the same way weather is inevitable, not predetermined in detail, but constrained by the landscape. The filament supplies, the cluster edits, the afterlife remembers. You can resist the words, you can't resist the slope. You've walked the river. Now, step through the gate. This is a city that orbits nothing but itself, a metropolis of 1,000 galaxies floating in a bath of hot plasma, wrapped in a dark halo so deep light bends and stumbles. We call it a galaxy cluster. It has an appetite, a climate, a history, and laws. If you want to understand the future of any galaxy unlucky or lucky enough to live here, learn how the city works. Appetite. What a cluster. Eats a cluster eats in 3 courses: filaments, groups, and loners. Filaments deliver the staples, steady traffic of dwarfs, dusty spirals, and thin gas streams. Groups arrive like container ships, pre-processed cargo, already arguing with itself, ready to be absorbed. Loners, individual galaxies on high-speed orbits, are garnish. The city digests them slowly but inevitably, one high-velocity pass at a time. Every bite adds mass to 3 ledgers: dark matter, the silent bulk, collisionless, shaping the city's potential well. Intracluster medium, ICM, hot X-ray bright plasma, the city's atmosphere. Stellar content, the visible citizens, galaxies, and the intracluster light, ICL, the ghostly population of stars stripped from their homes. The ratio is lopsided by design. Dark matter is the landlord. Gas is the weather. Stars, beautiful, noisy, and politically influential, are a minority party. Climate, the hot breath of the city. Inside the wall, the virial radius, the ICM sets the climate, 10 to 100 million Kelvin, thin by human standards, decisive by galactic ones. This atmosphere is pressure, drag, and memory. A newcomer plunges in and feels a wind not of air but of plasma, a ram pressure that scours cold gas from disks and paints, tails across the sky. Shocks ripple where subclusters collide, cold fronts, knife-edge temperature jumps, mark sloshing motions of dense cores through hotter surroundings. The ICM glows in X-rays with a brightness that scales with depth and density. That glow is an energy ledger, gravitational potential energy turned into heat as infalling gas is shocked and compressed, then radiated away over gigayears unless something keeps turning the thermostat back up. The thermostat, black holes. With city keys. Left alone, the densest central gas would cool, condense, and snow down onto the brightest cluster galaxy, BCG, lighting a storm of star formation that can't last. But clusters aren't left alone. The BCG almost always houses a supermassive black hole with jets that fire on duty cycles measured in tens of millions of years. Those jets inflate bubbles in the ICM, radio-bright cavities that look like footprints stamped into the X-ray fog. As the bubbles rise, they do PDV work, stir turbulence and seed sound waves. The energy couples back into the gas, offsetting radiative cooling. This is AGN feedback as public works, intermittent, local, and city-saving. Switch it off, the core catastrophically cools. Overdo it, the core withers. The surprising truth is how often the thermostat lands near balance. Cool cores that don't collapse, star formation that flickers rather than roars. A city center that stays poised instead of plunging. Clusters split into cool core and non-cool core personalities. Cool core cities have dense, low-entropy centers, gentle temperature gradients, and visible feedback imprints. Bubbles, ripples, filaments of cooled gas feeding the BCG in fits and starts. Non-cool core cities show disturbed cores, recent merger scars, and a rougher energy budget where large-scale weather drowns out precision climate control. Law and order. Orbits, relaxation, and the city's shape. Citizens follow the gene's law even if they don't know its name. Random motions supported by the gravitational potential. In a relaxed cluster, one that hasn't suffered a major merger in a while, galaxy velocities follow a near-Gaussian distribution. The density profile of dark matter is well approximated by a cuspy inward slope. Think NFW-like. The X-ray isophotes are rounder. The BCG lounges at the bottom of the well with only a tiny velocity offset. In a disturbed city, the laws still hold, but the streets are blocked. Velocity distributions become skewed or double-peaked. X-ray peaks and mass peaks separate. Gas lags, collisionless mass sprints ahead. You see radio relics tracing shock fronts at the outskirts and radio halos filling the middle with synchrotron haze. The law hasn't failed. The court is busy. A practical police tool is the phase space diagram, projected radius versus line of sight velocity. It's the city's dash cam. Infalling galaxies trace trumpet-shaped caustics. Backsplash citizens, those that cross the core once and escape to the outskirts, occupy a distinct band, red and gas poor even outside the wall. With phase space, you don't guess who has seen the city. You prove it. The tax records, intracluster light. Every tidal tale that never fell back, every shredded dwarf, every galaxy tussle that shook stars loose. These unpaid taxes pool into the intracluster light. It's faint, a few percent of the sky background per pixel in the best images. But integrated over the city, it's serious wealth, often 10–40% of the stellar budget. The ICL is the ledger of violence, a diffuse fog telling you how aggressively the city assembled. Scrutinize it, and you'll find shells, streams, chevrons, morphologies that can be time-stamped. Younger clusters keep their starlight closer to galaxies. Older, more cannibalistic cities have a broader glow. For observers, measuring ICL is an art of subtraction. Remove galaxy light profiles carefully. Model the point spread function wings. Dodge the traps of scattered light. For theorists, it's a test of assembly. Does your simulation produce enough or too much ghost light? Either way, the ICL is the city's collective memory, written in photons few bother to read. Strong governance, lensing, and mass. The city's sovereignty is mass. We weigh it with gravitational lensing, weak lensing, statistical subtle distortions in background galaxy shapes across the field. It maps the dark scaffold without caring about light. Strong lensing, arcs and multiple images near the center. It pins down the inner potential with surgical precision. Combine lensing with X-ray hydrostatic equilibrium and galaxy dynamics, and you get a multi-instrument symphony, independent judges agreeing or exposing bias. When lensing peaks are offset from X-ray peaks in mergers, you're watching different citizens obey different laws. Collisionless mass, dark matter plus stars gliding through. Collisional gas slowed and shocked. The textbook case is famous for good reason. It shows the city's layered society with a single image. Expansion projects, mergers, rewrite the law. Major mergers are city council overhauls at Mach numbers of 1 to 3. Two subclusters interpenetrate, launching bow shocks through the ICM. Cold fronts form as cool cores survive the first impact and slosh. Turbulence seeds cluster-scale magnetic fields, lighting relics at the periphery and halos in the heart. The BCG can be displaced, the AGN thermostat misfires, cooling pauses, entropy spikes. Over a few gigayears, the chaos relaxes into a deeper, larger city with a new center of power. During these expansions, the mass temperature, MT, and X-ray luminosity temperature, LXT scaling relations scatter. Afterward, they tighten again. Even in upheaval, clusters respect self-similarity statistics modulated by baryonic physics. Translated, gravity keeps the rulebook, gas writes the margin notes, the city's energy budget. Where does the energy come from, and where does it go? Infall heating, the dominant deposit. Gravitational potential energy converts to thermal energy in shocks. AGN feedback, periodic injection stabilizing cool cores. Turbulence and sloshing, redistribution rather than net gains, but crucial for mixing and transporting metals. Radiative cooling, the principal sink in dense centers, cosmic rays and magnetic fields, minority players with outsized influence on radio emissivity and transport. Balancing this budget is the central challenge of cluster climate science. The surprising outcome is that many cores hover near marginal stability, enough cooling to feed filaments, enough heating to prevent runaway collapse. Nature likes the thermostat set just below storm. Public transit, orbits, buses, and bridges. Galaxies don't take straight lines. They commute on orbits set by the mass profile. Radial orbits plunge deep, get stripped hard, and contribute generously to the ICL. Tangential orbits loiter, suffer harassment, and fade slowly. Tidal bridges, ephemeral star-lit highways connecting recent partners, glow for 1 billion years and then dissolve into the ghost population. Jellyfish tails sparkle with star formation before fading. Some clumps survive as ultra-compact dwarfs, shrunken survivors, cores without their original coats. 10. Health Department, quenching timescales. Environmental quenching in the city unfolds on 2 clocks. Rapid mode, Schroi 4 to 1 Geyer. Ram pressure stripping on first pericenter. Gas reservoirs lost. Star formation drops sharply. Slow mode, 2 for Geyer. Strangulation, the infall cut off. Residual gas consumed. Colors drift from blue to green to red. Mass quenching can preempt or reinforce this. Galaxies above a threshold halo mass build virial shocks and black hole regulation that quench even outside the wall. In the city center, you meet both fates intertwined. Climate plus self-control, environment plus ego. City districts by radius. Think of the city in rings, core, R0.2, R200, the BCG, cool core, if present, cavities and filaments, highest densities, lowest entropy, slow orbital speeds, red and dead, the norm. Inner city, 0.2 to 5 R200, mix of SIRS and spirals in late conversion, strong harassment, jellyfish frequent, X-ray brightness high, radio halos common in disturbed systems. Outskirts, 0.5, 1.0 R200, first infall traffic, pre-processed groups arriving, cold fronts at subcluster edges, radio relics near shocks, backsplash residents blend in. Beyond the wall, 1 to 2 R200, filaments proper, density just high enough to matter. The city's sphere of influence extends in phase space more than in projected distance. Each ring has its own statistics, its own crimes, its own weather. 12. Metals and memory. The ICM is not primordial. It's polluted by 1 trillion supernovae. Iron and alpha elements salt the gas in patterns that record where stars lived and died. Mergers mix these metals. Cool cores keep gradients. Observationally, metallicity gradients flatten in disturbed clusters and sharpen in relaxed ones. It's urban archaeology at 10 million degrees. Read the iron map, recover the city's last century. The city's press office, Sunyaev Zeldovich, SZ effect. Even clusters that are shy in X-rays speak in microwaves. The ICM's hot electrons inverse Comptons scatter cosmic microwave background photons, leaving a pressure-weighted fingerprint, the SZ effect. Unlike X-rays, SZ brightness scales linearly with density and is redshift independent, making SZ a clean way to count cities across cosmic time. Combine SZ with X-ray and lensing, and you pin down the pressure, density, and total mass, 3 angles on the same truth. The Mayor. Brightest cluster galaxy. The BCG is less a resident than an institution. It grew by minor mergers and cannibalism, puffed up by an extended envelope that bleeds into the ICL. Its stars are old, its color red, its velocity dispersion high. But it is not inert. Filaments of cooled gas can thread its halo. Nuclear activity turns on and off. Star formation bursts occasionally rekindle, leaving rings or knots embedded in the old glow. The Mayor naps, but the office never closes. Justice. Collisions don't treat everyone equally. Here is the city's harsh justice laid bare. Stars and dark matter pass through each other almost untouched in mergers. Gas does not. That inequity produces the most striking civic photographs, mass peaks and galaxy concentrations marching ahead while the X-ray plasma splashes behind. The visual is political. It tells you what the majority is made of and who feels the shock when policies change. Long-term urban planning. Fate of a cluster project forward in a universe where expansion accelerates. Beyond a certain epoch, the cosmic web's large-scale supply lines thin. Remote tributaries slip over the horizon. The city becomes an island universe, bound to itself, cut off from distant trade. Inside, evolution continues. Orphan light grows. Small satellites rain in. The BCG fattens. Cool cores cycle. Entropy creeps upward. On timescales longer than languages survive, the city outlives the map that named it. If you want permanence in a changing cosmos, clusters are as close as you'll get. Fieldcraft. How we know. We are not guessing. We image the X-ray atmosphere to take temperatures and entropies. We map weak lensing to weigh the scaffold. We time strong lensing arcs to pin down the core. We listen in radio for halos and relics. We trace HI and CO to watch gas stripping. We age date stellar populations. We stack phase space diagrams across many systems to read infall histories. We simulate the lot with gravity plus hydrodynamics plus feedback and ask if the synthetic city resembles the one we live near. Where the agreements are crisp, bubbles, cold fronts, jellyfish, ICL fractions, we trust the story. Where they aren't, we sharpen the tools. Ethics of a map, what the city teaches. The city cures us of the still sky illusion. It teaches that environment is destiny, and destiny is gradient. It warns against building theories around the brightest residents while ignoring the weather that rules them. It reminds us that memory lives in the faint, in ghostlight, in chemical maps, in ripples, in hot fog. And it offers a civic virtue worth stealing. Feedback is not a flaw, it's how stability survives. One walk through town. Take one slow orbit inside a relaxed, cool core city. You pass the BCG, red, immense, threaded by thin H-alpha filaments like veins under skin, with twin radio bubbles rising like lanterns. A few hundred kiloparsecs out, the X-ray brightness softens. You cross a cold front. Density jumps, temperature drops, pressure stays nearly continuous. The fingerprint of long-lived sloshing. Farther out, a faded spiral shows a ragged ultraviolet tail, newborn clusters glittering where stripped gas condensed in transit. Past half the wall, you catch a peripheral relic, a sickle of radio emission tracing an old shock. Beyond the wall, you step onto the filament, galaxies thicken into a lane, velocities align, and the hot breath of the city quiets. Turn around. Everything behind you is still falling in. The city's one sentence. A cluster is gravity's city. It eats by accretion, heats by shocks and black holes, rules by potential, remembers in ghost light, and evolves by mergers that rewrite its laws without changing its constitution. The river map of the universe has a blind spot that fooled us for ages. We honored wells and ignored roofs. We praised clusters for their gravity and treated emptiness as decoration, background paint behind the bright. That was sentimental, not scientific. The universe is shaped as much by what is missing as by what is present. This chapter is about the high ground, voids and repellers, where the potential rises, the density falls and flows, slide away like rain off a dome. It's the story of motion written by lack. The shape of nothing. Nothing is not flat. A large, underdense region is a hilltop in the gravitational potential. Gravity still only attracts, but gradients point away from that crown because mass outside the whole tugs harder than the little that remains inside. In a flow map, arrows radiate from void centers the way water lines separate on a roof. If you measure peculiar velocities, the true motions after subtracting cosmic expansion, you see galaxies drifting off the crown along sheets and filaments, just as they converge into valleys around clusters. Wells gather, roofs evacuate. Voids are not uniform balloons. They are scalloped basins with lumpy floors, threaded by wisps, mini filaments that never quite grew up, and bounded by walls where matter is piled up like snow at a curb. Some are compensated, their missing mass shows up in a sharp wall around them. Others are open bowls that just fade into the next district of the web. Their typical diameters span tens of megaparsecs. The grandest yawns, the famous textbook hollows, reach 100 or more. The Buddha's void earns its reputation because it combines two gifts, breadth and relative cleanliness. But every direction you look, at every redshift, the web alternates, knot, filament, sheet, void, repeat, living next to a hole. Where you are is where you're being taken, and a nearby void matters to your fate. Our own neighborhood rides the lip of a notable underdensity, the local Atio. Void, while our flows tilt toward richer districts, Virgo, Hydra Centaurus beyond. That push-pull balance is not poetry, it's arithmetic. The mass behind us is scant, so the net tug from the other side wins. In velocity reconstructions, you see a repeller in the direction of the local void, an effective source of divergent flow, while dense basins act as attractors. Together, they trace our town's arrow across the cosmic map. This is the most unintuitive piece of the whole story, so say it plainly. Emptiness can move you, not by pushing, but by failing to pull. Replace repeller with crown if the word bothers you. The math doesn't care which metaphor you prefer. The arrows do the same thing. How emptiness changes. With time, voids grow because the universe gives them room. Where density dips below average, expansion outruns collapse. The interior stretches faster than the surroundings. Matter trickles out along the steepest exits. The central density drops further. The edge sharpens. The wall fattens. On a time-lapse simulation, it looks like rising bread where the dough pulls away from the pan, lifting and thinning in the middle while crust thickens at the rim. Galaxies trapped on islands inside a void, tiny groups clinging to miniature filaments, live slow. Their gas isn't harassed by hot atmospheres. Their star formation sputters on sparse diets, gentle and prolonged. Dwarfs can thrive longer here than in the suburbs of a cluster. Because no one steals their groceries. The cost is isolation, few mergers, modest growth, and little external drama. Emptiness makes for quiet biographies. Edges that aren't walls. Void boundaries are transitions, not fences. Where the outflow from a void meets the inflow toward a nearby filament, you find a saddle, a pass between a crown and a valley. Those passes are the universe's decision points. Cross one, and you pledge allegiance to a different basin. In a watershed diagram, separatrix, the sheets where flow flips direction, wrap voids like origami. They are how you should redraw supercluster borders, by allegiance lines, not brightness contours. At these edges you also meet physics you can measure, Redshift space distortions stretch voids along the line of sight, galaxies running away faster than Hubble would predict, while walls appear squashed where coherent infall dominates. Stack enough voids and you can detect their weak lensing imprint, the slight demagnification from a deficit of mass and, in compensated cases, an excess at the rim. The empty has a fingerprint, it's just delicate. Cartography of repulsion. How do you chart a roof you can't see? The craft mirrors the valley work, build a distance ladder, subtract Hubble expansion, and plot peculiar velocities in 3D. Where arrows diverge, you infer crowns. Run reconstruction algorithms, think of them as denoisers that prefer smooth physical flows, and a void network appears like words bleeding through. A page. Confirm with galaxy surveys, count tracers to map underdensities, not just pretty spirals, but humble dwarfs and HI-rich ghosts. Voids found by density often align with repellers found by velocity, and where they don't, you learn about selection and bias, how light follows mass imperfectly. Different finders emphasize different features. Watershed methods grow basins from local minima in the density field until they meet. Graph methods knit low-density zones by connectivity. Dynamical methods use the tidal or velocity shear to classify space by expansion axes. Whichever you pick, remember the goal, not a catalog of holes, but an atlas of crowns that actually steer motion. The quiet engine. Behind the elevator. One seductive mistake is to place all the credit for recession on dark energy and expansion, treating peculiar velocities as minor graffiti on a grand, smooth canvas. Voids show why that's lazy. On scales of tens to a few hundred megaparsecs, exactly the scales that feel like local universe for any life that evolves on one rock, crown and valley structure sculpts the flow field decisively. Expansion is the elevator. Wells and roofs choreograph the shove in the hallway. If you want to know why your town is moving the way it is, count not only the cities ahead, but the empty prairie behind. Weather in nothing. You might imagine voids as sterile vacua. They aren't. They host miniature weather, tenuous filaments, tiny walls, and modest groups that are to clusters what villages are to capitals. Gas accretes cold, star formation ticks along at low surface densities, and feedback, winds from supernovae or central black holes, is often strong enough to unbind gas entirely from shallow potential wells. That's why void galaxies can be paradoxical, blue and youthful, but also fragile and gas-poor after one good blow. Shapes here are freer to keep their innocence. Disk galaxies retain well-ordered rotation, bars form and evolve secularly without the harassment that cities impose, and polar rings, gas captured on wild orbits, survive longer when no neighbor barges in to straighten them. If you want to study how galaxies behave without neighbors shouting, voids are the cleanest lab you'll get. Cosmology in the hollow emptiness is not just scenery, it's a measuring stick. 3 examples. Growth of structure. The speed at which voids evacuate and walls sharpen depends on how quickly gravity makes inhomogeneities grow. Measure the outflow pattern and you constrain the growth rate of cosmic structure, the famous Fs rate you see in papers, which in turn constrains gravity itself. Geometry via shapes. On average, stacked voids should be spherical in real space. If you observe them elongated along the line of sight after correcting for peculiar motions, you've learned something about the background geometry. Alcock-Pazinski test. It's a clean trick because voids don't have sharp centers you could bias as badly as with clusters. Imprints on the microwave background. Large voids can leave subtle cold spots, and sometimes hot rings, in the cosmic microwave background via the integrated Sachs-Wolf effect. Evolving potential hills slightly change photon energies as the universe accelerates. Stack many voids, and the signal emerges from the noise like a watermark. Add lensing by voids, a small defocusing, and redshift space distortions, galaxies falling off crowns stretch the map, and you get a suite of orthogonal probes. The hollow is cooperative. Case studies worth knowing. Local void, our backyard's crown. It's not empty, but empty enough that the surrounding web slides off its shoulder. Pair its push with Virgo's pull, and you retrieve much of the local group's peculiar motion. It explains why, away from nothing, is a direction that shows up in our velocity. Boot is void, the celebrity cavern. What makes it special is not absolute purity, but its photogenic contrast with surrounding walls. It's a teaching tool. Point a scope in a class at the same patch, and even a beginner senses the scale of absence. Dipole repeller versus attractor pairings. In reconstructed flow fields built from galaxy distances, you often see a push-pull duet, a prominent repeller roughly opposite an attractor. Visualize a globe with a thumb pressing in on one side and a palm pressing out on the other. Your town's arrow points from crown to valley. It's a mnemonic for motion that sticks. Perseus, Pisces, and friends, long walls that border voids act like levees. Map a void properly, and you discover its nameable neighbors, chains of superclusters whose scaffolding you'll otherwise mistake for unrelated islands. Fieldcraft, how we catch the invisible. You don't get voids for free, you have to sweat the selection. Bright galaxy samples bias you toward the Webb's cities and highways. You'll overestimate how empty the hollows are. Go deep for dwarfs and HI, and the emptiness gets populated by quiet citizens you were snubbing. Use uniform selections across the sky to avoid inventing fake holes where your survey simply ran out of patience. Cross-check density-defined voids with velocity-defined repellers. When both agree, you print the map with confidence. Distance indicators are finicky. Peculiar velocity catalogs scatter. Dust lies. Supernovae have moods. That's why void cartography is an ensemble sport. Average, smooth, penalize drama, and ask for coherence across independent methods. Never let a single finder define your world. Human-scale translation. If clusters are megalopolises, voids are high plains. A farm on a windswept plateau expands on its own schedule. No highway brings sudden crowds. No factory steals its kids for city wages. The town grows bars in its main street because the locals have time. It keeps its dialect because no one laughs it out of them. Drought, not invasion, is the main threat. When a dry year hits, the shallow wells cough and, the youngest, move away along the few roads that exist. The plateau isn't hostile, it's demanding. The meaning of community here is persistence, not spectacle. What emptiness teaches about bias? We're animals built to worship brightness and mistake crowding for importance. Voids expose the bias. Many questions in astronomy are really questions of selection, what we saw first, easiest, or with the instruments we had. Emptiness refuses those shortcuts. To honor voids, you have to count the faint, measure the subtle, and believe the arrows more than the postcards. That discipline inoculates you against your own favorite illusions. It also reframes average. The mean density of the universe lives nowhere in particular. You don't walk through average. You oscillate between scarcity and glut. A galaxy's biography is a series of negotiations with that oscillation, and void time is not wasted time. It is when a disk finds itself without being rewritten by neighbors, for better or worse. The ethics of absence. There's a philosophical dividend hidden in the hollow, the realization that absence is an actor. In science and in life, we like to assign causality to the loudest presence, but here, the cleanest explanation for immeasurable motion is the lack behind us. That truth softens a lot of human arguments. The missing funding shapes a field as much as the grant that landed. The laws you didn't pass change a city as much as the ones you did. In the sky, as on the ground, subtraction can be destiny. A walk across a crown. Stand at the notional center of a large void. Nothing obvious announces itself. The galaxy count is low, but not zero. The night looks normal if you lack a surveyor's eye. Start walking toward one rim and measure as you go. Velocities tilt outward, then gradually cant toward the nearest wall. Dwarfs become less shy. A thin thread of small galaxies aligns like fence posts in the distance. Beyond it, you see a proper sheet like a county line, and past that, a filament like a river road heading toward a city haze you can sense rather than see. Turn around in the middle, the arrows splay behind you like a dandelion. It's subtle, it's incontrovertible. Prediction from the hollow. Once you embrace crowns as seriously as valleys, you get better at forecasting. Ask, Which dwarf groups on the rim are likely to be captured by the adjacent filament in the next few billion years? Which saddles will migrate as the crown puffs and the valley deepens? Which mini-filaments inside the void will dissolve instead of hardening? These are not philosophical questions. They are initial condition problems. Feed the present-day field to a gravity plus hydrodynamics code and evolve forward. Compare the predicted capture and fade patterns against the actual census when you come back with deeper data in 10 years. If your flow map was honest, the rhyme between prediction and sky will improve. Practical use. Fixing your intuition. Here's the cheapest upgrade to your mental map. When you say nearest neighbor, add in my flow. Distance by ruler is a start. Distance by shared future is the finish. And when you draw a border around a supercluster, draw it where the arrows change sign, not where the light looks pretty. Teach this to students early, and you spare them the decade-long detour we took pretending the universe honored our postcards. Also, when a paper or video leans on a dramatic attractor to explain a motion, ask for the counterweight. Where is the crown on the other side? The best answers will show you both, with a saddle in between. That geometry is the signature of honesty. One sentence you can carry. Voids are not holes in a fabric. They are crowns on a landscape. Regions where the potential is high, matter is scarce, and flows diverge. So the universe's map is incomplete unless you chart the roofs that push as carefully as the wells that pull. You've walked the valleys and stood on the crowns. Now climb the passes that decide everything. Saddles and separatrices are the ridgelines of the universe, the knife edges where one drop of matter commits to one destiny and the next drop, inches away, commits to another. Clusters pull, voids release. The passes in between assign citizenship. If you want to draw borders that aren't lies, this is where you put your pencil. A saddle is not a place of rest. It is a point that is downhill in one direction and uphill in another, a crossroads of gradients. In a gravitational potential, the saddle is where flows split. Approach from the north, and you slide into basin A. Approach from the west, and you pour into basin B. The separatrix is the sheet, sometimes warped, sometimes crumpled, made of these knife edges stitched together. Cross it, and your long-term allegiance changes. Stay on one side, and every future orbit is flavored by the same valley. Think of the potential as a landscape of wells and roofs. In wells, all directions slope in. On roofs, all directions slope out. Saddles sit between them with mixed signs, some directions in, some out. That mixed signature is measurable. The tidal or Hessian tensor has both positive and negative eigenvalues there. Mathematicians will call these stable and unstable manifolds. Hydrologists will nod and call them watershed divides. Cosmographers will shrug and call them the only borders that mean anything. These ridgelines are not drawn on photographs. They are drawn on motion. Plot peculiar velocity arrows in 3 dimensions, real, measured deviations from pure expansion, and watch what the arrows do near a saddle. On one side, they curve toward a specific attractor. On the other, they peel away toward a rival. The separatrix itself is a place of exquisite ambiguity. An infinitesimal shove to either side determines eons of fate. That is why small errors in distance or flow reconstructions matter most in past country. A wobbly map moves borders. If you prefer density to dynamics, you can still find the passes, but you must be honest about the translation. Walls of galaxies, the sheets, often trace the separatrices because matter piles up where flows compress. Filaments snap to the skeleton where 2 such sheets intersect. Yet, brightness is a noisy proxy. Faint walls can be dynamically decisive. Bright knots can mislead if they're perched right on the divide. The cleanest borders still come from arrows. There's a Lagrangian versus Eulerian way of seeing all this. In the Eulerian picture, you stand at a fixed location and watch matter slide past, asking which way the arrows lean. In the Lagrangian picture, you tag a patch of matter in the early universe and follow it, watching which basin captures it when sheets fold and filaments sharpen. The old Zeldovich recipe is the intuition engine here. Start with small, smooth ripples. Let gravity amplify them. Watch axes collapse one by one, first a sheet, then a filament, then a knot where all 3 directions give way. Saddles are where one axis is on the verge of flipping allegiance. Observationally, you can't replay the film backward from today to the microwave background without assumptions, but simulations show the continuity. Today's borders are the evolved versions of yesterday's nearly flat passes. Supercluster names become meaningful only when tied to a separatrix. If you define a supercluster by light, galaxies brighter than some threshold within some radius, you'll inherit every bias your threshold carries and call it geography. If instead you define it by basin, galaxies whose velocity streamlines run to the same attractor through the same corridor, you get a political map that predicts the future. That is why, when we redrew the neighborhood and slapped a Polynesian name on it, the important act wasn't naming. It was agreeing to let borders follow flows. The border is not where the sky looks busy, it's where allegiance flips. These passes are not frozen. Voids expand, clusters fatten, and the separatrix migrates. Sometimes one basin erodes the headwaters of another and steals tributaries, a process river people call stream capture. In the Webb, capture happens when a nearby attractor deepens or a nearby repeller swells, nudging the pass a few megaparsecs and flipping the allegiance of entire groups. Galaxies do not change their minds. The landscape changes their options. If you run a simulation long enough, you can tally capture events, which saddles marched, which filaments swapped parents, which tributary groups now drained to a different city. The Webb is not a static lace, it is a drainage network under renovation. Because passes move, uncertainty belongs here. A separatrix inferred from sparse data can hop when you add 1,000 new distances on one flank or uncover a hidden wall behind the Milky Way's dust. That doesn't make the saddle unreal. It means you were undersampling a knife edge. The cure is redundancy. Combine velocity reconstructions with deep galaxy counts, weak lensing to probe mass where light lies, and radio or infrared surveys that ignore dust. If multiple lines of evidence mark the same ridge, print the border with a thicker pen. Now, stand on a separatrix and look both ways. To your left, arrows lean toward a cluster with an X-ray bright heart, a Mayer galaxy, and a banked reservoir of hot plasma that will strip and starve newcomers. To your right, arrows slide toward another basin, maybe less massive today, but with a corridor that feeds it cleanly from upstream filaments. At your feet, the sheet you stand on is a wall, the compressed residue where flows oppose each other and pile up. This wall is not a fortress, it is a traffic circle. Groups circulate, exchange members, and occasionally plunge across the ridge when the tide steepens on one side. Over 1 billion years, that exchange writes the demographics you can see. Spiral-rich associations on one flank. S-0 heavy associations on the other, jellyfish galaxies skewed in orientation depending on which wind they took into the city. The pass predicts the mix. A separatrix is also a mixing lab for spins. Along filaments far from passes, disk angular momenta tend to align with the street. Near the passes where sheets intersect and torques grow messy, orientations scatter and flip. That flip is a fossil you can still read. Misaligned gas disks, warps, polar rings that survived because the torque changed sign only recently. The pass isn't just a border, it's a torque factory. You can catch the passes at work in phase space. Plot projected radius versus line of sight velocity for galaxies around a metropolis. The familiar trumpet-shaped caustics mark the city's reach. Now, color points by which side of the pass they lived on before crossing the wall, information you infer statistically from group membership or from velocity reconstruction. Infowlers from different corridors occupy different stripes. Backsplash veterans carry the memory of which gate they used in their velocities and orbits. In a stacked sample of many cities, distinct funnels emerge for distinct passes. They are not random crowding, they are organized recruitment. Detection on the sky demands patience. Separatrices do not cast shadows, they are contours on a field you reconstruct. Velocity surveys give you the arrows, distances from Cepheids, supernovae, Mazirs, Tully-Fisher widths, surface brightness fluctuations, stitched into a catalog that lets you subtract expansion and trace the true shove. Run a flow reconstruction algorithm that penalizes drama and rewards coherence, and ask it where flow lines diverge. That is your first draft. Compare with a density-based skeleton. Find walls and filaments with a topological extractor that tracks ridges robust to noise and mark where walls face off. That's your second draft. Cross-check with weak lensing to be sure a bright wall isn't deceiving you with star formation. Where all three agree, you've got a pass. Because the passes are thin, instrument systematics loom larger. Distance ladders have rungs with scatter. If one rung is miscalibrated by 2%, your pass migrates. Bright time imaging spreads point spread function wings that masquerade as faint walls. Radio beams pick up side lobe ghosts. The antidote is obsession. Bootstrap the ladder, simulate the PSF, rotate the radio feed, test your ridgeline finder on mock skies where you know the truth. If your borders persist under abuse, they're worth naming. Everything we've said about ecology along filaments sharpens at the ridgelines. Gas inflow is anisotropic. Compression where streams meet can light star formation in the walls. The same compression can ram together dwarfs that would have sailed past one another in the open countryside, seeding groups that arrive at the city pre-processed. Even magnetic fields and cosmic rays care. Shocks along sheets, seed fields that later in clusters help sculpt radio relics and halos. The pass is not passive, it's a workshop. There is philosophy hiding here, and it is not subtle. We draw borders for comfort. The universe draws separatrices for truth. Political boundaries often slice through watersheds and call it sovereignty. Supercluster borders that slice through flow fields are the same kind of mistake. If you take seriously the idea that home is the set of neighbors who share your future, then the only honest home line is the separatrix. Everything else is cartographic nostalgia. Passes also tame arguments about coincidence. It can feel contrived that two bright chains of galaxies meet just where flows divide. It isn't contrived. The sheet is where opposing flows converge and compress. Filaments don't choose to attach there. They are born there. A pass is not an accident. It is the mathematically necessary seam between slopes of opposite sign. You may worry that dark energy's accelerating expansion will wash away the significance of all this. Not soon. Acceleration lengthens the elevator ride. It does not flatten your floor. Inside the island that your cluster and its tributaries inhabit, the ridgelines persist for giga-years beyond any era your language will name. Trade routes thin as the outer web slips over the horizon, but the internal watershed keeps its shape like an old country that outlived the empire's borders. If you want a human-scale translation, walk a real mountain pass. On one side, rain runs to one ocean, on the other, to another. A town built a mile this way trades north. A town a mile that way trades south. Their dialects diverge, their recipes evolve differently, and their histories rhyme with different capitals, not because anyone decreed it, but because mule paths and riverboats followed the slope. Move the pass by a ridge collapse or a landslide, and the trade maps redraw themselves without asking. That is separatrix logic, and it governs galaxies with the same quiet authority. There are practical payoffs. Survey time is finite. Aim your deepest spectroscopy along passes to sample both allegiances with the same instrument setup. You'll learn more about environmental contrast per hour. Target low surface brightness imaging of walls at the pass and you'll catch intragroup light being made in real time. Tidal feathers and shells that won't survive long in the open but glow here under gentle compression. Point radio dishes to measure neutral hydrogen along the ridge and you'll see which side is feeding its groups better. If you build a telescope schedule around borders instead of around pretty clusters, you will publish weirder, truer maps. Even at the level of a single galaxy's biography, the pass matters. A spiral that would have skated the outskirts of one city might, after a minor nudge to the ridge, tumble toward a more massive metropolis and quench sooner. The difference shows up not just in color, but in structure. A thicker disk from more harassment, a larger bulge from an extra round of mergers along the busier corridor, a different spin alignment written in the last torque the pass delivered. Two galaxies that look like twins today can diverge tomorrow because a separatrix wandered by a few hundred kiloparsecs. Fate is sensitive to borders. There's a poetry of regret here that belongs to maps. For a century, we wrote borders around brightness and told ourselves we were done. Then, the velocity field arrived with its arrows and made fools of our markers. The humiliation is healthy. It teaches the habit of asking the gradient before trusting the glow. It tells you to check the past before you write the history of a city or the curriculum of a galaxy. It whispers a better definition of close, not within X megaparsecs, but within the same basin past the same pass. Stand one last time on a cosmic ridgeline at dusk. The sky is ordinary. The instruments are not. You can't see the separatrix with your eyes any more than a farmer can see a watershed divide without thinking. But the arrows in your head make it visible. On this side, grains of starlight roll toward one gravity city, on that side, to another. The wind up here always feels like it is blowing both ways because it is. The slopes command it. You step forward 3 paces and commit 1,000,000,000 years to one future. You step back 3 paces and commit to another. The line between those futures is as thin as a thought and as real as a river. The web looks intricate because the beginning was simple. Start with a nearly featureless universe, hot and dense, with tiny ripples in density, 1 part in 100,000, laid down by physics that acted before light could remember it. Those ripples weren't decorations, they were instructions. Inflation stretched quantum jitters to cosmic scales, froze them into a pattern with a faint tilt, a touch more power on large scales than on small, and handed gravity a paw. Script, here a little extra, there a little less. From that whisper, everything followed. Wells, crowns, passes. The drainage network you've been walking became inevitable once the ripples existed. Before atoms could hold electrons, the universe was a plasma. Photons and baryons yoked together, behaving like a single fluid. Squeeze that fluid where a positive ripple lived and pressure pushed back. Gravity tried to compress, photon pressure tried to bounce, and the result was sound. Literal acoustic waves ringing through the early plasma. The crests marched outward at a set speed. The troughs chased them. In places with negative ripples, matter fled. In positive patches, matter briefly pooled, bounced, pooled again. Dark matter, immune to photon pressure, sat underneath as a silent scaffold, deepening the potential wells while the baryon-photon fluid sloshed on top. This duet left a ruler in the sky. When the universe cooled enough for electrons to bind to protons and the photons decoupled, the sound waves froze at a characteristic radius. Today, you can still see that radius as a gentle bump in the galaxy 2-point correlation function and as a pattern in the microwave, sky's temperature and polarization, an echo of a drum that stopped beating 13.8 billion years ago. Decoupling turned on a light. Photons streamed freely. We call their fossil glow the cosmic microwave background. The matter, now pressure-free on large scales, started to fall. Not all at once. There was a prior handoff when the universe stopped being radiation-dominated and became matter-dominated. Only then could small ripples begin to grow efficiently. Dark matter again did the quiet, heavy lifting. Where the initial field had slight overdensity, the dark scaffold deepened and pulled more in. Where it had underdensity, matter leaked away. Baryons lagged at first, their memory of the sloshing written in slight offsets and wiggles, then caught up as they cooled, fell, and lit stars. The growth was anisotropic because the initial field's curvature was anisotropic. Collapse along one axis built sheets, along 2 built filaments, along 3 built knots, exactly the taxonomy your feet have learned. Void, sheet, filament, cluster. You can write this story with calculus or with carpentry. Calculus calls it linear growth, transfer functions, and the Zeldovich approximation. Take the initial displacement field, push mass elements along the gradient by an amount proportional to time, and watch pancakes, sheets, form where trajectories cross first. Carpentry says it this way: stretch a rubber sheet with a fine pattern of shallow dimples, sprinkle ball bearings, let go. Bearings slide toward lines and intersections of lines. The earliest lines are faint, the earliest intersections are modest. Given time, and time is what the universe has, the skeleton sharpens. Nonlinear collapse bends straight lines, thickens them, spawns substructure, little knots on big knots, tributaries, feeding rivers, feeding deltas. Not all ingredients behaved the same. Neutrinos, light and fast, free-streamed out of small wells and suppressed fine detail, blurring the skeleton slightly below a characteristic scale. Warm dark matter would have erased even more small structure. Cold dark matter preserved it. Measure the present-day Webb small-scale crispness, and you back-solve what dark matter can and cannot be. Measure the BAO ruler, and you calibrate distance across cosmic time. Measure the slight tilt in the primordial power spectrum, and you read inflation's accent. These are not separate experiments. They are three views of the same yarn: initial conditions, growth, and the fossil record written in structure. Some of the most revealing fossils are the first lights. After recombination, the universe slipped into night. Gravity kept sowing, but no stars yet burned. Gas cooled in the dark, slid along new-made filaments, and gathered into halos that were finally dense enough for molecules to form and for cooling to accelerate. Somewhere between 100 and 400 million years after the beginning, the first stars lit. Massive, short-lived, fierce and ultraviolet. They didn't last, but they ended the night. Their photons ionized the fog, carving bubbles around young galaxies that grew, merged, and finally percolated until the universe was reionized. That transition left traces you can still hunt in the damping of small-scale fluctuations in the microwave background and in the Lyman alpha forest, the thicket of absorption lines in spectra of distant quasars that acts like a backlit map of the Webb's tenuous gas. Feedback joined the vocabulary right away. First stars blew winds and scattered metals. The first black holes launched jets. Supernovae carved chimneys in dwarf halos, sometimes evacuating them entirely. That mattered because the Webb's smallest tributaries, where gas density was lowest and potential wells were shallowest, were always the most vulnerable to being rewritten by their own children. In the countryside of voids, a single starburst could unbind a dwarf's gas and pause its biography for gigayears. Along filaments, fresh inflow replaced what was lost. In cities, hot atmospheres baked the gas before it could cool. The skeleton set the stage. The actors added weather. If you step back to data that anyone can hold in their hands, the logic stays tight. The microwave sky's tiny temperature ripples and polarization peaks are the phonograph grooves of the early sloshing. Their positions and heights pin down the contents of the universe. How much is ordinary matter? How much is dark matter? How smooth the initial field was? How quickly space itself now accelerates? Large-scale galaxy surveys transform the night into a 3D pointillist sculpture. Smooth the sculpture, extract its power spectrum, find the acoustic bump, and you measure distances and growth across epochs. Weak gravitational lensing, the systematic, subtle shearing of galaxy shapes, adds mass where light is stingy, drawing the scaffold underneath without asking it to glow. Put these together and you've trapped the story from two ends: initial whispers and present bones. The middle, the growth, has very few places left to hide. Even peculiar velocities, the tool we've been using to chart rivers, tilt their hats toward the first frame. The flows you see today are just the time-integrated gradient of the gravitational potential sourced by that barely tilted initial field filtered through the expansion history. Change the initial amplitude, flows scale. Change the tilt, different scales dominate at different times. Thread in a pinch of massive neutrinos, small flows damp relative to large ones. Shift the late-time acceleration, and while large distances grow faster apart, local shoves still write the municipal map. When you calibrate your velocity reconstructions against independent mass tracers, you are in practice cross-examining the growth history implied by the microwave sky. The fact that they agree within a stubbornly small set of arguments is one of the quiet triumphs of modern cosmology. There's a powerful geometric trick hiding in plain sight. All those early acoustic waves froze a preferred scale into the matter distribution, the co-moving sound horizon. Galaxies are not arranged on literal shells, but statistically, there's a bit of extra preference for pairs separated by that scale. Measure that bump at different redshifts, and you've built a yardstick with markings at multiple distances. The yardstick doesn't care about galaxy formation's messy details. It survives them because it's imprinted on the scaffold, not on any one resident. That's why the same ruler appears when you analyze the distribution of galaxies in redshift surveys, the absorption in the Lyman alpha forest toward distant quasars, or even the pattern of 21 centimeter intensity maps that average neutral hydrogen over large volumes. The universe left you a measuring tape in its very bones. The mathematics that predicts the skeleton's growth learned humility. Early on, linear theory and Press-Schechter arguments gave back-of-the-envelope halo abundances. Then, simulations taught us how halos assemble hierarchically, how substructure survives in larger hosts, how streams feed disks, and how feedback redraws baryons without breaking the collisionless scaffold. The web your eyes love in simulations, knots, filaments, sheets, voids, is not a special effect. It's the generic outcome of Gaussian initial conditions with a nearly scale-invariant spectrum evolving under gravity in an expanding background. Vary the inputs, and you distort the lace, warm the dark matter and the web smooths, add more massive neutrinos and small subhalos go missing, tweak the tilt, and you redistribute emphasis. That sensitivity is a feature, not a bug. It is how you turn pictures into measurements. This rewind to the first frame also reframes the language we've used. Attractors and repellers in today's flow field are deep-time descendants of peaks and troughs in the initial potential. The separatrices we drew as honest borders are the evolved versions of early time passes where the principal curvatures of the field flipped sign. The local sheet's gentle lamination is the fossil of a region whose initial deformation tensor had one axis only slightly more compressive than the others. Even the oddities, spin flips with mass, misalignments near passes, jellyfish tails that ignite star clusters while gas is torn away, are downstream of those same ripples, filtered through the city and countryside climates the skeleton creates. The arrow you feel under your feet has been pointing, softly, since before any star burned. None of this erases uncertainty. The distance ladder that feeds peculiar velocities is a stack of fallible rungs. Lensing systematics demand monastic discipline. Simulations still coarse-grained physics that stars and black holes perform in detail. But the many ways in approach boxes the errors. When microwave background inferences of initial conditions, baryon acoustic rulers of geometry, weak lensing maps of growth, redshift space distortions of the velocity field, and direct peculiar velocity reconstructions of local flows all point to the same drainage map, you lean forward, not back. The story that survives crossfire is the one that deserves to set intuition. There's a temptation, when a narrative hangs together this neatly, to baptize it with inevitability. Resist that. The web was not the only path. It was the path the universe took given the seeds it received. Change those seeds and the endings rhyme differently. If inflation had written more small-scale power, cities would have risen earlier and denser, and the countryside would have been harsher. If dark matter had been warm, the first towns would have been delayed and smoother, with fewer dwarf way stations along filaments. If neutrinos carried more mass, you would have shaved fine detail from the lace. We know these counterfactuals because we run them, then check against a sky that refuses to lie. The web you walk is contingent and at the same time robust against the many details you don't need to know to read a river correctly. Turn back to the human translation one more time. Imagine a flat continent with barely perceptible undulations impressed in the ground before anyone built roads. When rain falls, puddles collect where the ground was a hair lower, and trickles run where the slope, too small to see, still points somewhere. Give centuries for trickles to cut channels, channels to meet, and towns to rise at crossings. Give millennia for commerce to harden tracks into roads and for entourages to become cities. Walk the finished landscape, and you'll marvel at how naturally everything is arranged. Then someone shows you the initial survey, faint isohypses drawn long, before settlement, and you see that much of what feels designed is drift-obeying an old blueprint. That's what the microwave background is to the cosmic web, the old survey. That's what the BAO ruler is, the scale of the early slosh frozen into the map. That's what your local flow arrows are. Water, still obeying the undulations, long after towns learned each other's names. What you carry out of this rewind is not a new list of facts, but a sturdier instinct. When you ask why here about anything in the sky, your first reflex should be because of the gradient written then, not because brightness looks nice now. When you choose how to spend telescope hours, you bias toward measuring arrows and scaffolds, velocities, lensing, low surface brightness ghosts, over postcard gloss. When you explain to a student why voids matter, you don't say, because emptiness is interesting. You say, because the roof is half the map. When you think about the future of our town, you don't quote distances. You trace the corridor, the pass, the basin, and the crown, and you remember that all of them descended from ripples that barely existed. Rewinding also firms your sense of scale. A 1% change in initial amplitude ripples forward into a different head count of dwarfs, a different thickness of filaments, a different ease with which clusters quench. A tiny tilt in the earliest spectrum becomes a bias in where you find rich superclusters today. Slight neutrino masses that don't change chemistry in a lab still blur small pieces of the skeleton, enough to show up in lensing maps. The river is sensitive in all the places that make measurement fun and model building honest. The final honesty is temporal. We caught the universe in an era when both fossils and growth are visible. The microwave background still shines. The web is mature but not done. Rivers still feed cities. Crowns still evacuate their flats. Passes still migrate. Far ahead, acceleration will thin the outer supply lines. Your island city will become more alone. The old survey will be harder to read for residents who inherit a sky with fewer distant beacons. They will still be able to map their island with arrows. They will not be able to see the whole drainage network the way we can. There's a fragile privilege in living now. So when you step outside tonight, try a new layer of seeing. The Milky Way's river of light is parochial and gorgeous. Behind it hums the river of motion. Behind that, the bones of the web. Behind that, the frozen wavefronts of a plasma that hasn't existed for 13 billion years. Behind that, a field smoothed by a short, violent expansion that took quantum seeds and stretched them into a continent's worth of guidance. You cannot see any of that with your eyes. You can learn to feel it with your map. And once you do, every bright knot and every quiet hollow stops being an isolated marvel and becomes what it really is, the present tense of an old soft-spoken instruction still being obeyed. Bring the map home. You've toured the web at cathedral scale. Now shrink to the district where your own stars are citizens and read the arrows like street signs. Start on the raft you know, the local group. 2 big boats, the Milky Way and Andromeda, and a cloud of smaller craft roped to them by tides you can't feel. That raft is not floating on a pond. It's sliding along a laminated slab of space we call the local sheet, a thin plate of galaxies coasting together. On one side of that slab yawns a crown, the local void, whose lack tugs nothing, and therefore, by subtraction, helps set our course. On the other side lies thickening traffic, a filament that bends toward a brighter, hotter district we've spent lifetimes squinting at through our galaxy's dust. When you plot peculiar velocity arrows for thousands of nearby galaxies, subtracting the elevator of expansion and keeping only the hallway shove, the picture stops being romantic and becomes specific. Arrows lean away from the void and along the slab, then curl toward the city we call the Virgo cluster, and beyond that, toward a deeper basin that used to masquerade as a single monster when all we had were postcards between trees. The truth is less theatrical and more interesting. Not a lair, a valley mouth. Walk that itinerary in your head. First leg, from the local sheet's quiet to Virgo's outskirts. The rules change when you approach a city's wall. Gas-rich spirals that were blue and busy in the countryside grow jittery tails in the city wind. Dwarfs lose their groceries in one pass and redden. Groups arriving in convoy are already halfway resculpted by the gossip they shared upstream. You've seen this ecology from the city's point of view. From ours, the lesson is allegiance. Brightness can seduce, but allegiance is the better metric. A dim, edge-on spiral sliding along our street shares more of our fate than a flamboyant beacon just across the divide. If you teach students only one trick for reading the sky honestly, teach them to replace nearest by ruler with nearest by flow. Second leg. Follow the current past Virgo toward the wider basin. This is where old names used to trick us. The Great Attractor was a label for a direction where arrows converged through a belt of sky our own dust tried to erase. Infrared and radio peeled back the curtain, velocity reconstructions filled in the gaps, the one thing resolved into a corridor of influence, a ridge that funnels traffic toward a deeper well farther on. That deeper well helps explain why our local group's motion, measured against the microwave background's perfect average, points the way it does. The dipole you learn about, the fact that we are streaming through that universal rest frame at hundreds of kilometers per second, is not trivia. It is our civic speed limit sign. It's the felt consequence of living on a floor with slope. Third leg. Past the ridge and deeper yet, the slope steepens toward a heavyweight basin farther out. You don't need to memorize names to take the point. Flows stack. Valleys feed valleys. Corridors lead to busier corridors. Allegiance can cascade. The local group is not loyal to Virgo as a capital. Virgo itself is loyal to the deeper gradient that choreographs it. Once that sinks in, all the neat concentric rings you learned as a child, Sun, Orion Arm, Milky Way, local group, supercluster, feel like postal zones, useful for mail, useless for destiny. If you crave a single picture to pin on the wall, imagine painting the nearby universe with a dye that flows only along peculiar velocity streamlines and fades anywhere motion becomes chaotic. Your sheet lights up like a chalk line curling toward the wall of Virgo. The void behind glows only at its rim, where outflow meets inflow, and the pass rides like a saddle stitched into space. Beyond the city, the dye darkens along a larger lane until it dissolves into the haze of a basin so broad your eye confuses its depth for fog. That's the honest family portrait, home as an arrow, neighbors as co-movers, future as gradient. This bring-it-home lens clarifies arguments that used to spin in circles. Why do local maps drawn by light disagree with maps drawn by motion? Because light amplifies the loud and ignores the quiet. A single star-bursting dwarf can bias your sense of importance in a small patch. A dust lane can hide a wall. A cluster's X-ray furnace can monopolize your gaze, while an unassuming sheet next door quietly assigns half the region's citizenship. Velocity arrows are duller to look at and truer to the slope. If you must pick one picture to trust when the two disagree, pick arrows over glow. It also reframes what forecast means. We used to narrate the Milky Way Andromeda future as a two-body romance, then conceded the chorus, satellites, tides, and dark matter halos make it a crowd scene. The flow map adds the river. The timing and angle of the encounter live inside a corridor that nudges both boats' bows as they approach. The merger remnant, call it what you like, will not sit forever in a private moat. It will keep surfing the same street toward the same municipal complexes downriver until the external supply lines thin under accelerating expansion. Even then, the island city that remains will keep digesting what the corridor already cued. The forecast is not a date, it's a direction. You can see the same logic at village scale. Pick a group a few megaparsecs away, a handful of spirals in loose orbit, a couple of dwarfs on weird paths, a smudge of intragroup light nobody bothered to subtract well. The biographies of those members diverge not because of a single dramatic event, but because of angle and timing relative to the pass and the nearest wall. One grazes the city and loses gas in a jellyfish tail. One skims the ridge and keeps forming stars for another few giga-years. One plunges and reddens, then gets flung back as backsplash, wearing city scars in the countryside. The gradient wrote all three fates with the same pen. Once you accept this frame, you start asking better practical questions. Where do you spend your next 100 hours of telescope time if the goal is to tighten the local map? You don't chase the loudest showpieces, you stitch the passes, you plant your spectrograph along the separatrix where allegiance flips and sample both sides within the same instrument setup so systematics cancel. You pull low surface brightness exposures of the faint walls to catch intragroup light while it's still in coherent feathers instead of fully stirred fog. You take 21 center and CO maps along the ridge to measure how well the corridor is feeding its groups. You tip your weak lensing program slightly off the obvious cluster center so you can see the mass sheet beneath the pretty. You aim distance indicators, Cepheids, surface brightness fluctuations, supernovae, strategically at sparse patches where a single good arrow collapses uncertainty in a whole tile of the flow field. You stop doing postcard tours, you start doing drainage surveys. Accuracy loves redundancy. The zone of avoidance, our porch planks, still tries to trick you. Dust hides walls, optical light lies, even infrared has moods. So you braid datasets. If velocity reconstructions whisper that a ridge likely runs under the dust, you demand that a narrowband HI map or a deeper infrared catalog either agree or pick a fight. You add weak lensing to decide which storyteller is cheating. Wherever three independent methods point to the same slope, you ink it. Wherever they disagree, you camp until they don't. The honest map is patient. The same patience pays in translation. You may never teach someone to love eigenvalues of a tidal tensor, but you can teach any bright high schooler to stand on a real mountain pass and feel water's logic. From there, it's one step to supercluster borders as watershed divides, one step to the local void as a crown, one step to why our arrow points the way it does. The mental upgrade is worth more than the details. Home as an arrow inoculates a life against comforting stillness in more places than astronomy. There's also charity hidden in this map. When you watch a galaxy lose its gas and fade, you can tell truer stories than "it failed." It didn't. It took a road with a climate. When you watch one stay blue against the odds in a quiet sheet, you don't romanticize grit. You honor shelter. When you see a dwarf's gas vanish after one starburst in a void, you don't sneer at fragility. You respect the shallow well that made fragility inevitable. The river language humanizes outcomes without anthropomorphizing physics. Turn from ethics to edge cases, the ones that embarrass clean narratives. There are galaxies that look like they live in the wrong neighborhood. Red, quenched. Systems adrift in the countryside. Blue, gas-rich disks gasping inside the wall. Bright beacons perched on ridges that seem too faint to hold them. The drainage map doesn't hand-wave these away. It classifies them. Some are commuters caught in projection, living in the city in phase space, even if their projected address looks rural. Some are backsplash veterans, city-scarred and now outside the gate. Some rode unusual orbits through passes where torques flipped spins and left misaligned gas disks that disguise their history. In each case, a good phase space diagram or a clean velocity arrow moves the oddity from myth to file folder. Not rule-breaking, rule-illustrating. Now push farther ahead in time than any telescope schedule. Acceleration thins the outer web. The deepest basins keep what they've caught. Tributaries we can name today slide over horizons tomorrow. What remains for residents like us is an island city, a fattened merger remnant at its heart, a fog of ghost light pooled between the surviving citizens, a hot atmosphere that cycles between cooling and feedback under the mayor's black hole governance, and a sky where distant beacons have dimmed into silence. The drainage logic doesn't vanish in that future. It closes. Rivers that once crossed provincial lines now circle the same harbor. Maps simplify, arrows compress. The habit of seeing with gradients becomes even more valuable because the fossils we enjoy now, the microwave background, the acoustic ruler written into large-scale clustering, will be harder to read. In that loneliness, peculiar velocities and lensing inside the island keep the discipline alive. Still arrows, still scaffolds, still borders that aren't lies. There's a counterfactual worth tasting because it sharpens gratitude. If the crown behind our sheet were shallower, if a nearby rival basin were deeper, if the early power spectrum leaned a hair differently on the scales that carved our district, our arrow would tilt. Our raft might have joined a different city first, quenched earlier, or stayed rural longer. The biographies of every satellite you love to photograph, the Magellanic Clouds, the ragged streams wrapping the Milky Way, would rhyme differently. The point isn't to indulge what-ifs, it's to feel how sensitively today's quiet facts, the color of a satellite, the brightness of a tidal feature, the mere sign of our motion, are welded to old whispers. The universe under our feet is contingent without being chaotic. That is a scientific kind of awe. You can cash out this awe in small, practical rituals. When someone asks for a backyard sky talk, bring a sheet of paper and draw arrows, not only constellations. When a student wants a research project, give them a patch of sky near a pass and tell them to find both allegiances in one mosaic. When you plan a survey, budget depth for the faint, intragroup feathers, void galaxies that look like normal dots until you admit how alone they are, dwarf associations skating along walls. When you design a simulation, force yourself to predict a map of passes and compare it to the one a colleague built from velocities without seeing your code. Each of those habits moves a community from postcards to maps. There's a final flavor of bring it home that isn't technical at all. A lot of people carry quiet dread that scale erases meaning, that the bigger the universe gets in their mind, the smaller their lives feel. The drainage picture is a handrail against that dizziness. It doesn't belittle local stories, it locates them. Your city's weather, your species' choices, your personal loyalties, these are not made trivial by being nested inside a larger map. They are given context, like a town on one side of a mountain pass, learning why its recipes and songs differ from the town on the other side. The river does not write your lyrics, it writes your key signature. So take one last neighborhood walk, this time without instruments. Find the darkest place you can reach. Let your eyes fill with the nearby clutter, the band of the Milky Way, the triangles and kettles and hunters your ancestors named. Then add the layer your instruments taught you to feel. Behind the band, a sheet. Behind the bright knots, a traffic circle. Behind the quiet gap, a crown. Down the band, a street to a city and then to a deeper well. Beneath everything, a skeleton laid down by old ripples, still being obeyed. You are not standing under a ceiling. You are standing on a slope. Home is not a dot on that slope. Home is the direction the slope gives you, shared by every dim neighbor sliding the same way. Once you learn to love that arrow, the sky stops being a collection of ornaments and becomes what it has always been, motion you can't see, finely mapped. Start with the promise and work backward. You want a map that tells the truth, arrows over ornaments, so the final product you're after is a clean, peculiar velocity field, with uncertainties you can defend, streamlines that stay stable against mild changes in assumptions, and borders that follow separatrices rather than brightness. Everything you do from the first photon to the last figure is in service of that. The easiest way to keep yourself honest is to write the last paragraph of your paper on day one. Here is the flow, here is the error, here is where the border moves if I'm wrong. Then build the pipeline that earns those sentences. Photons arrive as gossip. Strip the drama. Put every measurement in a frame that knows which part is just the elevator of expansion and which part is the hallway shove of gravity. That means distances first, velocity second, frames last. Distances that don't depend on redshift are your lifeline. Close in, squeeze every drop out of geometry. Parallax for anchors, masers for exquisite black hole orbits that turn time delays into rulers. March outward with standard candles and yardsticks you've already cross-tuned against those anchors. Cepheids with stubborn period luminosity laws that you calibrate per metallicity and bandpass. Tip of the red giant branch for old populations where dust is modest. Surface brightness fluctuations for smooth ellipticals that whisper distance in their grain. The Tully-Fisher relation for spirals with good rotation widths and clean inclinations. Type Ia supernovae where the light curve shape and color correction earn their keep. Write down the scatter. Never trust a rung that doesn't advertise its wobble. Now, glue rungs. The temptation is to hand-wave cross-calibration. Fight it. Build a shared set of calibrators that sit on multiple rungs and force them to agree within error. If Cepheids and TRGB disagree in the same host by more than you can write off to dust or crowding, stop the pipeline and fix the physics or the photometry. A truth-first map starts with a humble ladder. Document 0 points like you document oxygen. With distances in hand, the velocity algebra is simple and unforgiving. You have CD, the recession inferred from redshift. You subtract the piece the background expansion would give you at that distance, h/0xd, to get the peculiar velocity. Everything you do to those two numbers, your choice of h/0, your choice of frame, your dust corrections feeding back into distance, imprints itself on the final arrows. Keep a version of the catalog where you can toggle H or 0 within the plausible range and watch how much of your map is a rigid rescaling and how much is a shape change. If the borders migrate wildly when H0 shifts by a few percent, you don't have borders, you have wishes. Frames matter because velocity is a conversation. You must say, relative to whom? Put your provisional arrows in the rest frame of the cosmic microwave background to remove our local sprint's projection on everything else. Keep a version in the local group frame to sanity check small-scale behavior. Be explicit about solar motion, local group motion, and any correction you apply for local bulk flows when comparing to old work. Ambiguity multiplies in the margins. Kill it early. The zone of avoidance is not an excuse, it's a test. Plan from the outset how you will bridge the planks our galaxy has laid across the sky. Infrared sees through dust. HI surveys draw walls and ridges in 21-centimeter emission where optical catalogs go blind. Targeted narrow-band campaigns can pick up line emitters that slip past broadband selection. If your map's most interesting ridge dives under the Milky Way and doesn't reappear, you haven't proved it vanished. You've confessed you didn't look. Now comes the step where artistry and discipline shake hands, reconstruction. A raw field of noisy arrows is not a map. It's grass in the wind. You want a flow that is physically plausible, respects continuity, and refuses drama that the data don't demand. Wiener filtering, constrained realizations, Bayesian velocity. Reconstructions that penalize curvature beyond what the uncertainties can support. These are tools, not religions. Choose one, write down its priors, and test it mercilessly on mocks that share your survey's footprint, depth, and selection quirks. Give yourself adversarial tests, hide a synthetic ridge under dust, remove an entire rung of the ladder and watch what collapses, generate catalogs with a wrong H0 and ensure your code refuses to invent curls to compensate. The goal is not a pretty flow. It's a flow that would rather be boring than lie. Visualization is not decoration, it's detection. Arrows plotted naively turn to hay. Switch to streamlines seated carefully along walls and filaments. Use line integral convolution to reveal coherent features without inventing them. Color is an argument. Reserve saturation for confidence, not for beauty. Overlay contours of the reconstructed potential so you and your reader can see the wells, the roofs, and the passes without flipping pages. When brightness maps and flow maps disagree, lean into the disagreement. This is where the map teaches. Label those zones. Light says A, motion says B, here is why we trust B. And back it with uncertainty patches, not adjectives. The map is only as honest as its errors. Publish them like you publish results. For each region, give the arrow and its ellipse, not just a mean and a smile. Show border drift when you perturb H0, when you downweight a rung, when you blank the zone of avoidance and fill it with a prior. Admit the places where your reconstruction is prior dominated. You'll be tempted to delete panels that look messy. Keep them. A reader who can see where your map goes wobbly is a reader who will believe you where it doesn't. Science lives on pre-mortems. List the failure modes before a referee does. Distance ladder systematics, crowding in C-fides, metallicity dependence in TRGB, Malmquist bias in Tully-Fisher, light curve training set biases in supernovae. Velocity pitfalls, flow aliasing where a sparse region artificially smooths away a real wall, spuriously large peculiar velocities from dust-induced underestimates of distance, redshift misassignments in confused regions, reconstruction sins, over-smoothing that erases passes, under-smoothing that turns noise into curls, boundary conditions that bake in a phantom bulk flow. For each failure, write your mitigation. Deeper calibration fields, mock catalog abuse tests, cross-checks with weak lensing where the mass doesn't care about light. The humility buys you trust, and paradoxically, bolder conclusions. Choose casework that proves your pipeline earns its keep. Pick one known city and one quiet sheet. In the city, make jellyfish galaxies your lie detectors. Their tails point opposite the wind that stripped them. If your reconstructed wind disagrees with a dozen tails, your flow is wrong, not the jellyfish. In the sheet, use low surface brightness intragroup feathers as drift tracers. These tidal threads are fragile and align with gentle compression. If you need a crosswind to explain them, you're inventing weather. A map that predicts the angle of a tail before you measure it is a map that can be trusted where tails are scarce. Spin is another check that sneaks up on you. In the countryside and along filaments, light disks tend to have spins aligned with the street. Heavier halos flip, near passes, orientations scatter. Predict, then verify with integral field spectroscopy and HI velocity fields. If your ridgeline makes a clear prediction, in this corridor, intermediate mass disks should show a bias toward spin filament alignment, go look. The failure of a prediction is a mapmaker's friend. It tells you where the slope you drew is honest and where it was an artifact of selection. Designing a survey with arrows, not postcards, in mind changes everything from exposure times to field placement. You don't point at the loudest cluster. You tile along the separatrix where allegiance flips so the same instrument, on the same night, sees both sides of a border. You budget depth for faint walls that spawn intragroup light because feathers, there are the living minutes of galaxy assembly. You request 21 cm time for the same corridors, so you measure whether gas supply supports the star formation you infer. You arrange your cadence to catch type Ia supernovae in galaxies with distances from other rungs, not because you love redundancy, but because the latter gets stiffer every time two rungs share a host. When you propose weak lensing near the pass instead of dead center on the city, you look eccentric for a week and prescient in a year. The elephant you can't ignore is calibration tension writ large. H0 shifts by a few percent, and your arrows tilt, flow magnitudes scale, and some passes migrate. Treat this not as a crisis but as a stress test. Build two maps bracketing the tension, publish both, and quantify which features are invariant. This ridge exists, and this border holds for any H0 in XY. This other feature is conditional. You'll find that allegiance, more than speed, is robust. The direction of downhill survives modest fights about the elevator's pace. That's good news for borders and bad news for punditry. Lensing is your reality check when light lies. Weak lensing doesn't care if a wall is dusty, faint, or bored. It cares about mass. Overlay lensing convergence on your reconstructed potential. Agreement earns you swagger. Disagreement earns you a week in the penalty box re-examining selection and priors. In mergers, where gas lags and collisionless mass sprints, strong lensing arcs around the mayor's palace will tell you if your city center's potential is centered where your flow says it should be. If the lens says the mass sits under the BCG and your flow insists on a displaced well, you've either found a true asymmetry or a reconstruction that curved to please itself. Once the map is stable, use it to make forecasts that can be wrong within a human grant cycle. Pick 3 groups approaching a city along different corridors. Predict with error bars, which will strip hardest on first pericenter, which will quench slowly by strangulation, which dwarfs will arrive as jellyfish versus arrive as ghosts. Publish target lists with watch this tail form by 2030 and go back. A field that trains itself to hazard near-term falsifiable predictions gets young fast and honest faster. You will be tempted to turn your discussion into a hymn to your favorite attractor. Balance the choir with the roof. For every paragraph about the pull that wins, write a paragraph about the lack that loses. Show the crown on the other side of your town's arrow. Draw the saddle between them. Every time you include both, you train a reader and yourself to think in gradients rather than mascots. There is pedagogy buried in these choices. If you want a student to feel why borders should follow flow, don't start with tensors. Take them to a river confluence or a mountain pass and make them point where rain goes on either side. Then hand them the sky equivalent, a phase space diagram where 2 infall funnels from different passes overlap and backsplash citizens hide in plain sight. They will never again be satisfied with a ring drawn around brightness and called a supercluster. You won't either. Let your figures tell the story you claim to believe. Open with light only, because that's what the eye expects. Then overlay faint transparent streamlines. Then remove the light and leave only arrows and potential. The moment where the reader realizes the map still makes sense with the ornaments gone is the moment you've won. End with a single panel that shows border drift under all your perturbations. If the line wiggles but does not wander, print it bold. If it wanders, leave it gray and admit that you owe the truth a deeper look. No map survives contact with a new catalog unscathed. Plan for the update. Write the code so it eats new distances without tantrums, new lensing layers without special pleating, and new 21 centimeter walls without moving goalposts. Archive not only your best map, but also your mocks and your abuse tests. Invite strangers to try to break them. The cartography that outlives you is the one that doesn't need your laptop to run. There's a small vital habit that seems like style, but is ethics. Name things by what they do, not what they look like. Call something a pass if it flips allegiance, a wall if it compresses flows, a city if it rules by hot breath and potential, a crown if arrows diverge. If a bright knot sits on a pass and tempts you to label it a city, make the arrows talk you out of it. Language can be a soft lie. Make it answer to motion. And because the sky is bigger than your grant, pick a square and own it. Adopt a patch that includes a pass, a piece of a wall, and a stretch of corridor. Build its ladder deeper than anyone asked you to. Measure its lensing with the patience you meant to save for a vacation. Chase its jellyfish and its feathers, its dwarfs in the hollow, and its bright boastful spirals on the ridge. Publish the arrows with error ellipses so large they embarrass you the first time and less the second. Watch your border wander and settle as new calibrators land. Teach 3 students to love that patch, then hand them the keys. In 10 years, 1,000 tiny, honest patches stitched together will beat any single glossy mural. If you keep the last promise, truth over ornament, you get a bonus. The field doesn't talk about enough. Peace of mind. A map that prefers being boring to being wrong is a map you can sleep under. The night will still be busy with cities eating, crowns exhaling, passes migrating, and corridors delivering citizens to their fates. But your role in the story is clear. You are not the poet of the glow. You are the surveyor of the slope. You draw borders that don't lie, arrows that don't flatter, and futures that can be checked. That discipline is a kind of freedom. It turns a sky of pretty distractions into a landscape you can read, revise, and trust. And when you step outside after the figures are done, no telescope, no code, just eyes, you'll notice what the work has done to your seeing. Constellations will sit politely where they always have, but you'll feel the sheet under the band, the crown behind the quiet, the pass where 2 bright chains meet and secretly oppose one another, the corridor down which your whole town is sliding whether anyone votes for it or not. You'll hear the wind that jellyfish prove, and the hush where intragroup feathers curl. You won't say any of this out loud at the backyard party. You'll just smile at a sky that stops being a ceiling and becomes what it has been all along, a slope you learned to measure, a river you learned to map, and a border you finally had the nerve to draw where the arrows told you to. Start where confusion usually starts, with the pretty lie that brightness tells the whole story. It doesn't. You know that now. But habit is stubborn. The sky still tries to sell you ornaments. Your job is to keep asking for arrows. When a map looks persuasive because it glows, demand the gradient. When a claim sounds profound because it names a monster, ask to see the separatrix it rules. Once you do that enough times, the old illusions come into view like stage props in daylight. You can name them, dodge them, and teach others to see through them too. The first illusion is symmetry worship. We love circles, so we draw round borders around busy regions and call the result a supercluster. The web doesn't care. Flows are lopsided. Valleys feed from one side more than the other. Crowns bulge toward their nearest rival, and separatrices snake. If your border is pretty, it's probably wrong. Let ugliness be a tell for honesty. Jagged borders that follow streamlines will age. Better than handsome halos drawn by hand. The second illusion is proximity by ruler. That one dies hard. 2 galaxies the same distance from you can be strangers in fate, one sliding along your corridor, one across the ridge, and a dim companion along your flow will matter more to your future than a spotlight across the divide. Nearest without "in my flow" is a half sentence. Train yourself to finish it. The third illusion is mascot thinking. We name an attractor, then we bend the map to flatter the name. The universe dislikes mascots. What you called a lair was a valley mouth fed by many ridges, and what you called a single authority was a committee of gradients stacked across scales. Use names as bookmarks, not explanations. If the arrows contradict the mascot, retire the mascot. The fourth illusion is snapshot certainty. Still images look decisive, motions are noisy, but gravity writes in verbs. A faint tidal feather is a sentence fragment that only makes sense if the background wind points the way your reconstruction says it does. Jellyfish tails are sworn affidavits written in gas. Phase space funnels are the court calendar. Prefer minutes to portraits. The fifth illusion is cleverness over calibration. It's intoxicating to run a powerful reconstruction and print a flow that looks like art. If the ladder is wobbling underneath you, all the cleverness in the world is theater. Calibrate rungs with cruelty. Force Cepheids to respect TRGB in the same host. Make Tully fishers submit to galaxies you have better rulers for. Publish the fights your rungs had and how you made them shake hands. A boring ladder is a beautiful map. The sixth illusion is mistaking a pass for a wall and a wall for a city. Walls compress, cities rule, passes decide. If all you have is a brightness map, walls often look like cities because crowded light is photogenic. The cure is the same, arrows first. When you honor the pass, many previously weird features, misaligned spins, shells at odd angles, groups that seem pre-processed too early, become simple consequences of torque and traffic. The seventh illusion is thinking uncertainty is decoration. It isn't. It is the part of the map that keeps the rest of the map honest. Error ellipse on arrows and border drift bands on separatrices are not optional. They tell you which predictions are worth money and which are worth coffee. If a conclusion cannot survive being plotted next to its uncertainty, it wasn't a conclusion. Once you can spot those illusions, you can build habits that inoculate a lab, a survey, even a classroom. Start with paired sight. Every time you show a light-only panel, pair it with an arrow-only panel of the same patch. If colleagues resist, insist. The moment someone admits that the arrow-only panel still makes sense is the moment you've earned a convert. Follow with honest overlays, potential contours that expose wells and crowns, streamlines that refuse to bend, where the data don't. Finish with drift disclosure. A small gallery of how borders move under plausible A-0 ladder or zone of avoidance changes. A reader who sees your map dance a little and not fall apart will trust your music. There's a practical classroom translation that works even if students never touch a telescope. Bring a basin, sand, and 2 watering cans. Shape a faint ridge. Pour from one side, then from the other. Watch where channels form, where separatrices appear, how a small change in the ridge height flips allegiance for half the sandbox. Then, put down the cans and show a phase space plot, the same logic in dots. When a teenager can point to the real pass on their backyard hill and tell you which ocean a raindrop will meet, they are one step from seeing why a supercluster border drawn on GLOW is sentimental, not scientific. Turn to the part of the field that loves to argue, tensions and crises. You'll hear about the HR0 disagreement. You'll hear about small-scale puzzles, missing satellites too big to fail, planes of satellites that look too organized. You'll hear about ultra-diffuse galaxies that seem to ignore rules. You'll hear about bars and disks that appear too quickly in some simulations and too slowly in others. The drainage frame does not magic these away. It organizes them. H0 tension, build 2 flow maps, bracketing the range. Report the features invariant to that choice. You'll discover allegiance is stubbornly robust even when speeds scale. Missing satellites? Ask where dwarfs were expected to survive, in crowns, along thin filaments, inside groups, and where climate and feedback make them fragile. Too big to fail? Check which halos live near passes where torques and tides complicate naive abundance matching. Planes of satellites? Look for the print of a narrow corridor. Anisotropic infall along one street makes a plane look less miraculous. Ultra-diffuse galaxies? Inspect the wind history. Ram pressure and tides in outskirts can puff a system while sparing enough stars to make it photogenic. Bars? Remember that bar instability growth is a dialogue between internal disk physics and the torque field. Along some walls and passes, spins and torques align to accelerate bar birth. None of that hand waves the puzzles away. It replaces mystery with testable context. The best tests are predictions that embarrass you if you're wrong soon. Choose nearby corridors with good distance anchors. Predict which infalling groups will deliver the most jellyfish on first pericenter. Predict the handedness bias of disk spins in a named filament segment. Predict where intragroup feathers will be thickest along a wall because compression is gentle and long-lived there. Publish that list, time-bound it, and let graduate students go hunting. A field that bets on near-term falsification grows teeth. Beyond astronomy, gradient thinking travels well. Once you train yourself to replace mascots with slopes and ornaments with arrows, you notice the same pattern in places that have nothing to do with galaxies. In seismology, faults are ridgelines where stress flips allegiance. In hydrology, watershed divides already carry the gospel. In traffic, desire lines and bottlenecks act like filaments and passes. In economics, capital flows obey gradients more than slogans. The ethic carries too. Publish uncertainty, name things by what they do, and let borders follow flow, not hype. That cross-training makes better scientists and less gullible citizens. Reproducibility is not a checkbox in this business, it's self-defense. A drainage map's credibility rests on other teams being able to feed your code their distances and get your borders. That means shipping not just figures, but pipelines, mocks, and abuse tests. It means archiving the exact rung calibrators you forced to agree and the exact priors you fed your reconstruction. It means documenting your PSF wings so an intracluster light result can be believed. This sounds like clerical work. It's cartography. The only map that matters is the one strangers can redraw and still recognize. Citizen science has a role if you craft it carefully. People with backyard scopes and patient eyes can measure surface brightness better than you expect if you give them honest targets and calibration rituals. Aim them at walls where intragroup feathers live, not at bright city centers. Teach them to dither, to subtract the sky with religious care, to guard against scattered light. Pair their images with your streamlines. The first time a volunteer's faint plume lines up with your predicted wind, you've earned an ally and, maybe, saved yourself dozens of hours of telescope time on features the big programs don't prioritize. There's an interpersonal ethic hidden in border work. Drawing separatrices that flip allegiance is political even if you pretend it isn't. It changes what gets targeted, funded, and named. If you're going to move a border someone has loved for 20 years, do it with receipts, velocity arrows, lensing convergence, and a clean treatment of the dust belt. Then give the old name a dignified afterlife. Keep it as a district within the flow-true border rather than erasing it from the vocabulary. This buys you cooperation, where defensiveness would have cost you data. All of this builds toward a simple, usable practice for anyone who wants to work in this style. Adopt a patch. Make sure it includes a pass, a wall, a piece of corridor, and, if you're greedy, the edge of a city. Build the ladder deep. Calibrate the rungs until they stop arguing. Reconstruct with a method you can defend without metaphors. Overlay lensing where you can. Collect jellyfish, feathers, and spin measurements like stamps along your border. Publish arrows with their error ellipses and borders with their drift. Predict 3 showpieces and revisit them. Invite rivals to break your map. Then hand the patch to a student with better taste and let them make it leaner. If your interests are more theoretical, write the same ethic into code. Don't just match counts of halos. Generate synthetic peculiar velocity catalogs through your mocks with the same footprint, depth, and ugliness as the real survey. Run your reconstruction blind on the mocks and demand that it find the passes you know are there and fail to invent ridges where you didn't put them. Tie your simulated phase space diagrams to the real ones by the same selection functions. Simulations, like telescopes, are gossip machines until you make them testify under the same rules. There's a part of the work that is not technical at all, learning to talk about arrows without turning them into poetry or boredom. People hate being lectured with jargon. They also hate being conned by mystique. The voice you've been reading is the compromise, concrete metaphors that cash out, rivers, crowns, passes, paired with specific checkable claims, phase space funnels, jellyfish tails, lensing peaks. Keep that balance and you'll recruit minds that would otherwise have bounced off the field. Lose it, and you end up with either sermons or textbooks no one finishes. One last practical ritual. Write your conclusions twice. First, write them like a brag, short, punchy, confident. Then, write them again as a test plan. What would make you withdraw each sentence? That second set of bullets is your next year of work. If a border moves more than your drift band when H0 shifts by 1 sigma, fix the latter or fix the prior. If jellyfish tails disagree with your wind more than once per corridor, revisit your smoothing. If lensing and potential contours quarrel, investigate dust, selection, or the temptation to massage. A field that writes its retractions in advance has fewer later. You'll notice as this becomes habit that the sky stops arguing with you. It doesn't owe you clarity, but it likes being asked the right questions. When you approach with arrows instead of ornaments, with borders that follow flow instead of glow, with uncertainty that is part of the figure and not an appendix, the answer is usually gentle. Yes, there is the ridge. Yes, there's the crown. Yes, the pass moved when you deepened the ladder. Yes, the jellyfish tell the wind you drew. The rare times the answer is no are the days you should celebrate. That no is where you were flattering yourself, not physics. That's where the map gets better. And because the work reteaches your eyes, take them outside again. No instruments, no acronyms. Feel the slope. The band of the Milky Way is not a decorative sash. It's a lane edging a sheet. The dark quiet patch is not nothing. It's a crown. The angle between two bright chains is not an accident. It's a pass daring you to draw a border that flips allegiance on either side. The slow drift your city feels relative to the microwave background, the scrim of the universe, itself, is not trivia. It's the sum of ridges and roofs you now know how to map. Lean into that knowledge without getting romantic about it. You're not the hero, you're the surveyor. That's enough. It is more than enough. You've unlearned the postcard and learned to read the slope. Now put the habit to work until it becomes second nature. Start with a simple ritual. Before you look at any pretty picture, galaxy zoo, deep field, cluster glamour shot, close your eyes and say, what would the arrows look like here? Then open them and try to infer the wind from what little the light betrays. A jellyfish tail pointing away from the city's breath, a faint intragroup feather curling along a wall. Disk spins that rhyme with a corridor, a phase space funnel that tells you who's arriving and who already paid taxes at Perry Center. You won't be right every time. You'll be right often enough that the brain rewires. After a month, the sky in your head will always be overlaid with streamlines, and you'll wonder how you ever believed the ornaments. Make the habit quantitative in small, respectful steps. Pick a nearby patch that is data-rich but human-sized. Half a dozen groups strung along a modest filament with a city's wall at one end and a crowned shoulder at the other. Don't chase completeness, chase coherence. Build its ladder with two independent rungs so you can triangulate. TRGB distances in the smooth old ellipticals, Tully Fisher for the clean spirals, a couple of type Ia supernovae if the universe is kind. Put every arrow on the same frame and keep the error ellipses big enough to embarrass you. Smooth with a method that punishes drama more than you do on your best day. When the flow field seems to make sense, stop and ask what would falsify it here. What single new distance at the pass? What weak lensing convergence ridge under the dust? What jellyfish tail at the outskirts would force you to redraw a border? Those what-ifs are not thought experiments. They are a one-night proposal list. A serious map is a to-do list with streamlines. Train your eye on misfits with generosity, not impatience. A quenched dwarf in the countryside is not automatically a mistake. It might be backsplash, a veteran of the city sleeping under stars it no longer trusts. A blue spiral inside the wall is not a rebuke to the climate. It may have skimmed the edge, inhaled deep, and carries its last reservoir through one more orbit before the wind wins. A bright knot on a faint ridge might sit on a pass where compression is high, even though the light is shy. Instead of forcing every oddity to kneel before your priors, let the oddities tell you where the slope is kinked in ways you underestimated. They're not exceptions to physics. They're footnotes to your map. Put time into the quietest signal you can afford to measure: ghost light. Intragroup and intracluster light look like clutter until you teach your telescope and your reduction pipeline to be monastic about scattered light, flat fields, and sky subtraction. Once the fog appears for real, it becomes a ledger. Feathers connecting victims to thieves, chevrons that timestamp a past flyby, outer envelopes that whisper how cannibalistic a city has been. Nothing will convert a glow lover faster than laying a ghost light map over your potential contours and watching the fog brighten exactly where the slope says it should. Nothing will convert you faster than the first time your predicted traffic circle glows with faint stars you did not expect to catch. Spin is the other quiet teacher. It doesn't require X-rays or million-dollar jets. It requires integral field spectroscopy for a few dozen disks in and around your ridge and the stubborn will to measure orientations honestly. Light disks along the street should prefer to spin with axes roughly parallel to the corridor. Heavier halos should flip that preference. At the pass, scatter should blossom. You won't get a perfect signal, you'll get a bias. That bias is the signature of the torque field, a fingerprint you can lay on top of your streamlines and say, the river isn't just ferrying mass, it's tutoring angular momentum. The first time the spin bias agrees with your predicted torque along a wall, you will stop caring whether your figure looks like art. You'll care that it's true. Build yourself a book of small, rude tests that cost little and say a lot. Jellyfish heads plus their UV bright beads down the tail give you wind direction on a plate. If a dozen in one corridor defy your arrows, your smoothing is lying or your distances are. Phase space caustics at the wall tell you which funnels are feeding. If a group straddling the pass sits outside where your model says it should be inside, revisit the border. HI morphology is the poor person's ram pressure meter. Asymmetry and truncation on the windward side are signatures you can quantify with one night on a dish. A low surface brightness plume aligned with a wall is a compression barometer. Catch a few and you'll know which side of the pass is feeding better. These aren't decorations, they're bolts that keep your bridge from humming itself to pieces. Expect to be wrong in public. Write down 3 predictions for the next season whose failure you would print without drama. This group, arriving along this corridor, will show the highest jellyfish fraction on first pericenter. Disk spins in this filament segment for masses between A and B will show a 10-degree alignment bias with the street. The intragroup light between these two named galaxies will arc in this direction, not that one. Say when the test will be visible. Say which instrument can catch it. Say how big you expect the effect to be and how loudly you will admit defeat if the result says otherwise. A community that lets itself be wrong quickly gets honest quickly. The arrows don't punish hubris, silence does. Bring humility to H0 without letting it paralyze you. The elevator's speed leaks into your peculiar velocities, and small shifts scale your arrows. Build 2 flow maps that bracket the current tension and show which borders are stable, which move, and which dissolve. You'll find that allegiance, the sign of the slope, is stubborn even when pace wobbles. You'll also find the passes most sensitive to H0 are places where a cheap new rung pays outsized dividends. Aim a rung there and watch a whole border snap into focus. It's satisfying the way tightening a drumhead is satisfying. One twist, better music. Resist the urge to make your reconstruction cleverer than your ladder. Aggressive methods can paint curls and swirls that look like physics and are really penmanship. Set your priors to be boring. Punish curvature unless the data scream for it. Test on mocks with your actual footprint and ugliness. Hide a ridge under dust in the mocks and make sure your code fails to invent it. Remove a rung and make sure your flow loses confidence instead of growing a personality. Inject a wrong H0 and make sure your map scales rather than bends. An algorithm that prefers dull truth over exciting invention is not underpowered, it's sober. Treat the zone of avoidance like a colleague you refuse to ignore. Infrared will pierce some of it. HI will sketch the bones of walls. Narrowband tricks will pluck line emitters from the murk. Lensing will lay mass down where light sulks. Never let a ridge die under the Milky Way without a fight. If you must publish a gap, fence it with honest priors and a clear statement of what you refuse to guess. Your readers will forgive blank space. They won't forgive decoration where a plank should be. When you communicate the work, keep a promise you made to yourself at the start. Metaphors that cash out, rivers, crowns, passes. Keep them only while they match arrows, potential, and phase space you can plot. The minute a metaphor stops paying rent, retire it. People smell when they're being sung to. They warm to being trusted with specifics. If you show them a jellyfish tail and a wind vector the map predicted months ago, you've earned 15 minutes of their attention without a single adjective. If you overlay lensing convergence on your reconstructed potential and the peaks shake hands, you've earned 30. Bring students in with small victories that feel like light bulbs, not hurdles. Give a teenager a shallow IFU data cube of a handful of spirals and a map of your corridor. Let them measure spin axes and test the alignment bias. Let a meticulous night owl reduce intergroup light on a patch where you know a feather should faintly glow. Give them the patience tricks, dithers, rotating the field, building empirical PSF wings from bright stars, and watch them grin when the fog appears exactly where the contour says it should. Give a future engineer a phase space diagram and ask them to draw the caustics by hand, then compare with the automatic extractor. None of those require a PhD to begin. All of them convert people to the Church of Arrows. If you write code, write it like you expect a rival to use it. Archive the mocks, not just the figures. Ship the abuse tests, not just the pipeline. Pin versions of the rung calibrators with the photometry that force them to agree. Document your PSF wings if you publish Ghostlight. State your priors and show where they dominate before a reviewer drags it out of you. Reproducibility is not a style point. It's a survival strategy for truth in a field that can decorate its way into a corner in a week. Think about the future with both optimism and restraint. New surveys will hand you distances by the tens of thousands with better systematics. Weak lensing will be mapped to a depth and breadth we use to call science fiction. Wide HI programs will sketch walls and void rims where optical sees fatigue. You don't need to list acronyms to know what to do with them. Spend those riches on passes first, cities second. Use the depth to thicken ladders where a single rung flipped borders, not to publish murals with more dynamic range. Use the breadth to chase crowns you could only infer before, not to redraw the same city with nicer colors. The temptation to turn abundance into ornament will never go away. Neither should your refusal. Let the other sciences seep into your craft, not for analogies, but for instincts. Hydrology will keep reminding you that borders drawn against watersheds are lies. Seismology will teach you to read stress fields and ridge lines where failure switches sides. Traffic flow modeling will caution you that desire lines and bottlenecks make filaments whether or not the city council draws a road. Economics, at its rare, honest best, will whisper that gradients and constraints beat mascots and slogans. You are not being profound when you make these connections. You are being practical. Gradient thinking is a muscle you can train across domains and then bring back to the sky stronger than when it left. Let yourself end days tired for the right reasons. Tired because you calibrated rungs until they stopped arguing. Tired because you threw out a pretty reconstruction that was lying. Tired because you stayed up for a jellyfish that finally lit its beads along the tail and told you the wind you drew was pointing the right way. Tired because you wrote the uncertainty panel that made your main figure look less bold but more honest. These are the hours that accumulate into a map you can sleep under. And keep a private ledger of wonder that does not require superstition. You can stand under a dark sky and feel something like reverence without assigning agency to gradients. The slope is enough. The fact that our raft's arrow is the integrated outcome of ripples set before any star burned is enough. The fact that a faint plume of starlight curls exactly where a line on your laptop said it would curl months before. The night was clear enough to catch it, that's enough. The fact that a cluster's hot breath carves bubbles that rise like lanterns and heat the air just enough to stall a collapse, it's engineering at a scale that humbles, not mystifies. You don't need more, you can want less. When you've built a few patches this way, passes inked, borders drifting modestly under perturbations, winds checked by tails and spins, and ghostlight, stitch them. Don't leap to a world map, sew a quilt, respect where seams show, publish the unevenness instead of smoothing it away. The map that earns trust is the one that admits its scars and gaps and keeps growing honestly in public. If you never get to the glossy version, you've still done the part that matters. You've converted a piece of sky from a story about brightness into a story about motion, with receipts. And then step outside one more time, without instrument, without agenda. Let your learned layer float behind your eyes. That bright chain is a wall. That emptiness is a crown. That fork is a pass you've argued about in print. That city's breath is a wind you've measured in tails and beads and missing gas on the windward side. The Milky Way is the parochial lane you love. Behind it is the sheet you ride with your neighbors. Beyond that is the corridor your raft drifts down, whether you write papers about it or not. You are not seeing secrets. You are seeing public facts with a trained mind. That is the whole gift. It doesn't make you special, it makes you responsible. So the next time someone hands you a persuasive mural of the local universe, drenched in flawless glow and labeled with heroic names, be polite, be grateful, and then ask the only question that matters. Where are the arrows? If the answer is a finger waved toward the brightest knot, smile and go back to your patch. If the answer is a set of streamlines that survive being poked, a border that moves a little and not a lot when you push H0, a handful of jellyfish whose tails agree, a ghost light arc that actually glows where the contour says it should, shake their hand, borrow their code, and add a square to the quilt. Bit by bit, the ceiling will finish turning into a slope in enough minds that postcards can retire with dignity. Bit by bit, the map will become the thing you promised yourself on day one. Arrows over ornaments, borders that don't lie, and futures that can be checked. Start with a week that could be any week and make it a case study. Monday morning, you pin a small rectangle on the sky, 4 by 8 degrees, anchored by a modest wall with a suspected pass on its north edge and a corridor bending south toward a city's outskirts. It is not famous. That's why you chose it. You inventory what exists. 32 reliable TRGB distances, 21 Tully-Fisher spirals with clean inclinations, 4 Type Ia supernova hosts with light curves you trust, a smattering of surface brightness fluctuation. Measurements in old ellipticals, and a handful of masser distances in the larger neighborhood to lock 0 points. You bracket H0 with 2 values, not because you enjoy indecision, but because you refuse to sneak certainty into the first plot. You write the boring line in your lab book that matters more than any figure. Targets that move the border if measured well. By Monday afternoon, you've cleaned and homogenized velocities into the microwave background frame, audited redshift flags, and parked every distance with its scatter where anyone on the team can see it. You run the reconstruction with priors tuned to be dull. Smoothness, penalties high, curl penalties active, boundary conditions that don't allow your box to pretend it knows the universe outside its walls. The first flow pops out like a whisper. Arrows bend along the wall, peel at the suspected pass, and arc toward the corridor. You're not allowed to like it. You're allowed to try to break it. Tuesday is for abuse. You drop the 2 supernovae and rerun. The pass wiggles half a degree but holds. You downweight Tully-Fisher by 30% and rerun. The wall's compression softens, the pass gains uncertainty, the corridor remains. You push H0 high, then low, and stare at what changes shape versus what scales. Allegiance doesn't care, speeds do. You smear the zone of avoidance with a lazy prior, and your flow tries to invent art. You slam the penalties back up, and the curls die. You replace the infrared catalog that pierced the dust with the shallow one your younger self would have used. A ridge disappears under the Milky Way. You put the deep one back and watch the ridge return. This is how you learn to dislike your own cleverness and love your ladder. Wednesday belongs to the sky. You've reserved time on a dish and an optical cue. The HI night goes after 10 spirals right along the wall. Windward and leeward sides sampled deliberately, because asymmetries in the gas disk are a cheap wind vane. You keep the spectra ugly, no smoothing to please a plot, and you keep a notebook line for each. Truncation on approach side, lopsided tails, warp orientation versus predicted streamline. Before sunrise, you have answers you can stand on. 7 show windward truncation aligned with your predicted wind within 20 degree. 2 are ambiguous because bars confuse the velocity field. 1 contradicts you and earns a sticky note that says, "Go back, check distance." The optical cue spends its patience on ultra-deep low-surface brightness exposures between 2 mid-mass galaxies. Your flow flagged as a slow squeeze pair on the wall. If a feather exists, it should arc with mild curvature toward the pass. You won't see it tonight. You will see it if your reduction pipeline respects darkness, like a monastery respects silence. Thursday is spins. A friendly IFU on a medium telescope gives you velocity maps for 14 disks you pre-selected by mass and environment. 5. Along the corridor, 5 near the pass, 4 on the quieter flank of the wall. You don't need perfect inclinations. You need honest axis angles and the courage to publish a bias rather than a parade of anecdotes. You translate those maps into spin axes on the sky and compare with your wall vector and corridor direction. The result is not a press release. It's better. Along the corridor, light disks show a weak but real alignment with the street. Near the pass, scatter blooms. On the quiet flank, alignment returns but with a broader spread. You don't declare victory, you write, torques along wall appear to tutor spins as predicted, passes scramble. Friday you devote to the zone of avoidance because it always tries to steal your weekend. Infrared dots sketch the ridge under the Milky Way. HI fills gaps with confidence. Lensing refuses to perform because stars and dust turn the sheer catalog into porridge. You accept the blank where you must. You fence it with conservative priors, and you put a translucent band on the figure that says, "We're honest here." It costs you glamour. It buys you trust. By Friday afternoon, the first reduction of your low surface brightness imaging arrives. It's noisy and full of ghosts, the kind that don't belong to physics. You pull out the long, boring scripts that build empirical PSF wings from bright stars in the same field and subtract scattered light with a paranoia you reserve for this one job. The fog retreats. The galaxy pair you flagged as a compression lab reveals a faint arc, 0.3% of the sky background, bridging them with the same slight convexity your potential contours predicted. You do not call it beautiful. You call it expected. That's the point. You don't do science alone, so Saturday belongs to politics done responsibly. You bring 2 colleagues who have disagreed with you before and ask them to try to break the border. One insists on switching to the local group frame to test small-scale sanity. The structure is unchanged, only speeds adjust. The other demands a blind test, hide a third of the distances, let them reconstruct with their preferred smoother, and see whether the pass survives. It does within half a degree. You concede their point that your prior still nudges the wall to be straighter than the light suggests. They concede your jellyfish directions, and HI asymmetries are unambiguous. You all agree to publish a drift band for the separatrix under 3 perturbations. H0, rung reweighting, and zone of avoidance masking. If the border still looks like a snake, you'll print the snake. Sunday is when you write the 3 predictions that will embarrass you if you're wrong. You pick a group crossing the wall that will hit pericenter in less than a giga-year and commit highest jellyfish fraction on first pass among the 3 named groups. You pick a filament segment and commit intermediate mass disks will show a 10-15 degree median alignment of spin axes with the corridor. You pick the faint feather and commit brightness profile will show a gentle gradient consistent with adiabatic compression, not a sharp step consistent with a recent, violent encounter. You give them dates and instruments. You tell a student which to chase first. Nothing in that week is glamorous. That's why it works. The border you will draw around the pass on this small patch that will not be pretty. It will be true enough to survive being kicked, and that is enough. Multiply this week by 50 patches and you will have a quilt, not a mural. The quilt will outlive fashions. You can build second layers on top of the week as your appetite grows. The first is a living error map. Instead of a single flow field, you publish a small ensemble, say, a few hundred constrained realizations, that all respect your ladder within uncertainties. You compute streamlines in each and tally how often any given pixel belongs to one basin or the other. The result is a border probability, not a line, but a band. Darker where allegiance is robust, paler where the separatrix roams under perturbation. You overlay jellyfish vectors, HI asymmetries, spin axes, and ghost light arcs, and watch where reality agrees with the mode and where it sides with an outlier. When tails and feathers vote against your median, you look for unmodeled structure, not for excuses. The second layer is time. With a good enough ensemble of flows, you can evolve test particles forward under a smoothed potential to forecast allegiance shifts, stream capture across the pass, and the birth of new faint walls. You do not sell this as prophecy. You sell it as, if nothing dramatic happens off-screen, this is the drift. You mark out which groups will likely be backsplash after 2 orbits, which corridors will thin as the outer web relaxes, which mini-filaments inside the nearby crown will dissolve instead of hardening. You do this not to impress a general audience, but to give yourself and your students targets that prove the method live. The third layer is names, which you treat with caution. You do not baptize a pass until arrows have earned it. When you do name, you choose verbs in geography that don't pretend to authority, ridges after local stars, saddles after minor rivers, corridors after the towns they thread, so that language remains descriptive rather than mythic. The old mascots can stay as district labels inside flow-true borders, like neighborhoods inside a city whose official lines were redrawn. That way, you respect history without lying to the map. At some point, you will face an outlier big enough to tempt you to contort your ethic. A bright, red, early-type galaxy in the quiet countryside looks like an environmental crime scene, but every indicator says it has never been inside the wall. You will be tempted to declare a revolution. Don't. You run phase space for that patch and discover the galaxy is a commuter in projection, its line-of-sight velocity, and position place it inside the infall trumpet. But its projected radius fooled your first pass. Or you find it sits on a deep mini-well at the intersection of 2 thin walls, quenched by its own black hole rather than by climate. Or you learn its gas was lost in a group flyby long before the city was built, a fossil of old harassment in a young district. The answer is rarely, your framework is wrong. It is usually, your picture was incomplete. The framework's strength is that it tells you where to look for the missing piece, along a corridor, at a pass, in a phase space funnel. If you want a different flavor of test, pick a well-known city, one with pretty X-ray bubbles and strong lensing arcs, and use the same ethic to study a less glamorous ring at 0.5-0.8 of the wall radius. That is where jellyfish roam, where slow strangulation competes with a few violent stripping events, where groups arrive half-baked by pre-processing. Publish a census that ties tail orientation to your wind, spin scatter to your pass, ghost light thickness to your wall compression, and lensing convergence to your potential contours. The city center will always get the press. The outskirts will get you the truth. You will encounter the perennial fight about the best reconstruction. Don't take the bait. The best is the one that fails honestly. If a method produces beautiful curl patterns in regions where your ladder is thin, it is bad even if referees clap. If a method erases passes that your jellyfish and spins insist exist, it is bad even if the figures are clean. If a method complains loudly, big uncertainties, fat drift bands, in the same patches where your data are sparse, it is good even if your ego wants narrower lines. The rule that survives every argument is simple. Reward methods that prefer to be boring and ignorance. If you have the patience to manage people as well as pixels, formalize the week into a playbook a student can run. Day 1, homogenize distances, bracket H0, first reconstruction. Day 2, ablations and priors, produce drift bands. Day 3, wind check with HI, wall check with low SB imaging. Day 4, spin bias along corridor and pass. Day 5, zone of avoidance cross-checks, lensing overlay if possible. Day 6, adversarial review with an outside pair. Day 7, publish 3 predictions with timestamps. Tape it to the wall. The first time your lab ships 2 patches a month with this rhythm, you'll feel the quilt grow under your hands. When you present this to a crowd whose appetite was trained on postcards, expect skepticism and be kind. Show light only first because you respect eyes. Then show arrows only and let the room feel the weird thrill of a map that still makes sense without ornaments. Then add tails and feathers and spins like signatures that agree with the slope. Then remove the light again so people leave with the right image in their head, borders drawn by motion, not glow. The minority who stay after will be the ones who make the next patches with you. You can future-proof this habit against the flood that's coming. New surveys will hand you rivers of distances, walls of lensing, sheets of HI. Resist the urge to drown in murals. Pre-commit to spending the first year of any new dataset on passes. The places where allegiance flips are where the dataset pays back its cost fastest, because one good arrow there reclassifies dozens of galaxies on either side. The city centers will always be there later. The passes move as you add data. That's the game you want to play. If you need a private reason to keep going when the week feels repetitive, keep a short list of the moments that paid rent. The first time a jellyfish tail you hadn't seen yet points exactly along a wind you predicted months before. The first time a feather you coaxed from noise arcs along your contour like a taut string. The first time a student draws their first phase space caustics by hand and gets the funnels right. The first time a rival's reconstruction agrees with yours in a place neither of you expected. These are small events. They are also why you do this instead of making prettier postcards. Close the loop with a quiet, necessary vow. You will not let names or glamour bully borders. If a famous label wants to swallow your pass, you will defend the ridge with arrows and receipts. If a glossy map draws a circle around brightness, you will write the polite email that asks for the gradient plot. If your own figure starts to look too handsome, you will add the drift band that mars it and saves your integrity. If a student shows you a pretty curl where the ladder is weak, you will hand them the eraser and teach them that sobriety is not the enemy of discovery. It is its bodyguard. Do this for a year and the sky around your patch will change in your mind. You'll stop seeing a ceiling and see a slope. You'll stop saying nearest and start saying nearest in my flow. You'll stop trusting mascots and start trusting passes. You'll start asking better questions of every glamorous paper and every budget request. The work will be slower than a press cycle and faster than folklore. Bit by bit, your quilt will grow. Bit by bit, the map will stop flattering the glow and start telling the truth in arrows. And when someone whispers that all of this is fussy, remind them of the week. One small rectangle, one honest ladder, one ridge under the Milky Way rescued from dust, one feather exactly where the contour said it should glow, one set of spins aligned where the street said they would be, one separatrix that moved a little and not a lot under every poke. That's the whole craft. That's the difference between a ceiling and a slope. That's enough work for one lifetime and room for 10 more. Scale up without losing the ethic. One patch becomes 5, 5 become 50, and suddenly you're not just mapping, you're organizing a small country of data and people. The trick is to keep the craft local while the standards go global. You don't centralize taste, you centralize calibration. Publish a common 0-point pack for distances that any team can adopt without surrendering their independence. Ship the exact CFID fits and TRGB edge detections you used, the photometry apertures, the crowding masks, the metallicity corrections, the light curve training set for Type Ia supernovae. Make it boring to disagree about rungs and exciting to disagree about passes. The quilt grows when patches snap together without a committee meeting. Let machine learning in like a contractor, not a magician. If a network helps denoise velocities or infer flows in gaps, it needs to speak physics, hardwire symmetries, translation invariants so the same pattern means the same thing in another corner, curl penalties so the network prefers potential flows unless the data shout otherwise, continuity so arrows don't vanish midstream because a training set was lazy. Train on mocks that look like your footprint with your dust belt, your depth, your selection ugliness. Withhold the quadrant you secretly care about and see if the model invents ridges where only wishful thinking lives. Make the network report uncertainty, not just a pretty vector field. A flow without error bars is a vibe, not a map. If you can't get a gradient out of it, you can interpret. If the saliency points to brightness instead of arrows, send it back. The sky doesn't owe you a neural poem. Design instruments around passes and climate, not glamour. Low surface brightness imaging gets easier when the telescope is designed to hate scattered light from day one. Baffling that isn't an afterthought, coatings that don't lie to the blue end, a calibration plan that spends as many words on flat fields as on field of view. Integral field units for spin work don't need flagship apertures if your target list is smart. You want clean disks along a corridor and around a pass, not a hero spectrum in the city center. HI time pays best when it straddles the separatrix. Asymmetries, they're red like wind veins. X-ray snapshots in the outskirts matter more than another deep stare at the mayor's palace. RAM pressure signatures and group pre-processing live where press offices ignore them. Weak lensing should be tiled to include walls and saddles with the same care you give the downtown peak. Mass underglow is the whole point. Build a calibration economy that rewards humility. Every time two rungs share a host and agree within error, bank the credit publicly. Every time they don't, write the ticket in a ledger everyone can see. A community that treats 0 points like a public utility stops wasting grant cycles on the same argument. Put bounties on the ugliest problems, empirical PSF wings in the red, dust corrections in crowded fields, Malmquist bias in Tully-Fisher catalogs when selection creeps. Pay in authorship, not applause. The fastest way to upgrade a field is to make it personally rewarding to fix the plumbing. Turn prediction into a sport where people don't lose their shirts but do lose their pride. Publish dashboards with time-stamped forecasts, jellyfish fractions for named groups at First Perry Center, spin bias amplitudes along named corridor segments, brightness and curvature of specific faint feathers, void outflow rates in patches stacked by environment. Tie each forecast to the data stream that will test it, surveys scheduled, instruments named, dates approximate, but honest. Celebrate the wrong calls that sharpen the map faster than the right ones that flatter it. A lab that is proud of retractions and course corrections becomes a place where students learn courage, not performance. Teach arrows early enough that they overwrite the postcard before it hardens. Intro labs can do this without telescopes. Give them redshift catalogs and a ladder of toy distances with scatter baked in. Have them compute peculiar velocities, draw phase space funnels for a synthetic city, and locate a pass-by eye. Hand them a deep image crowded with scattered light ghosts and make them build empirical PSF wings from a bright star, subtract, and watch a feather appear where a contour predicted it. Let them measure spin axes from IFU cutouts and test a weak alignment along a mock corridor. None of this needs a PhD to begin. All of it trains a reflex. Ask for arrows. Use the web to test hard physics instead of only telling pretty stories. Void outflows constrain gravity's growth rate. Stack them and pull on the same FS-8 rope the redshift distortion crowd tugs, but from a different angle. Baryon acoustic shells and galaxy clustering calibrate geometry. Void shapes give you an Alcock-Patzinski check that isn't chained to city centers. Neutrino masses smear small structure. Weak lensing of walls and corridors at modest redshift, combined with your flow field, puts a hand on that blur from a scale the microwave sky can't touch alone. Modified gravity writes bigger signatures in low-density regions than inside hot cities. The roof is where alternative laws either breathe or suffocate. The drainage map isn't just a language, it's a lever. Expect the future to be abundant and design restraint now. When distances arrive by the tens of thousands and lensing by the billions of shapes, your first instinct will be to write murals. Resist. Spend the first season on passes. Identify where allegiance flips changed most between your last patch and this flood, and aim rungs there. Build an interactive error atlas for the public that shows border probability, not just a single heroic line. Let people drag a slider for 8-0 and watch which seams wander and which hold. Give them spins and jellyfish overlays they can toggle. Turn education into participation without turning participation into hype. Fix how we name things before language turns to concrete. The old labels can live as neighborhood names inside flow true borders. You. Don't erase a century of habit by sneering. You rename gently with receipts. Ridges get names after local features, saddles after rivers, crowns after winds. Make names boring. Save excitement for proof. If a donor or press office begs for a monster, give them a corridor and teach them to love the word. Keep one eye on the edge cases that smell like a clue. Planes of satellites aren't magic when a corridor is narrow and arrivals are anisotropic, but some planes are too crisp for comfort. That's where you ask if your torque field got lazy or if your dwarfs are lying about their distances. Ultra-diffuse galaxies hovering in outskirts look less mystical when a long, gentle wind and tides can puff them without murder, but some are truly dark matter poor. Those you pin on past harassment and a shallow well, not on a violation of the scaffold. Bars that appear early or late relative to simulations are not invitations to declare the code broken. They are reminders that bars are conversations between disk physics and local torque, and your wall may be speaking louder than you modeled. Keep a file called "I hope this hurts me" and put the offenders there. If they survive 3 rounds of honest checks, you've got a project that matters. Write software like you expect to be sued by your future self. Freeze versions of rung catalogs with the exact 0 points and photometry. Ship the mocks that match your footprint and your ugliness. Include the abuse tests in the repository. The underdust ridge you hid, the wrong H0, the missing rung. Treat your reconstruction priors like citizens deserve to be told what law you used. Document PSF wings so someone else can make your ghostlight not a hallucination. If a stranger can't rerun your pipeline and get your borders within the drift band, you didn't publish a map, you posted a picture. Don't let the zone of avoidance be a permanent alibi. Build narrowband filters that target specific lines to fish galaxies out of dust. Push radio time to sketch walls where optics choke. Use CMB lensing as a mass layer behind the Milky Way's varnish. If you must leave a gap, draw it frankly and put a to-do tag on it, not a flourish. There's dignity in admitting what you haven't earned. Keep philosophy as a servant, not a master. It's fine to enjoy the idea that absence, acts, and borders should follow flow. It's not fine to let a metaphor override a tale that points the other way. Every noble sentence you write about rivers and crowns needs to cash out in a number a telescope can check. If a teenager can't test it with a calculator and a plot, it's sermon, not science. The sky rewards specifics. Remember the far future without getting melodramatic. Acceleration will thin the outer web. Supply lines will fade. Your island city will keep digesting what the corridor already queued. Residents born into that loneliness will still be able to map their island with arrows and lensing. They won't have our fossils, but they'll have our ethic if we write it down. The best bequest isn't a catalog of names. It's a culture that refuses ornaments without arrows and publishes uncertainty as proudly as results. You can't control who funds what in a century. You can control how you tell the truth now. Practice small acts that make a map sturdier than your ego. If your border looks handsome, look again. Add the drift band. If a jellyfish tail disagrees with your wind, publish the disagreement before someone else does. If lensing peaks grumble at your potential contours, don't massage them into alignment. Find the mass you missed or admit the model is tired. If your student finds a ridge where you had declared a calm sheet, hand them first authorship, not a lecture on taste. The craft outlives you when you make it safe to be right against you. Braid with other fields because gradients are universal. Hydrology keeps you honest about borders. Seismology teaches you to respect ridgelines where stress flips and failure travels. Traffic flow reminds you that desire lines and bottlenecks write filaments whether or not a council draws a road. Even epidemiology will teach you that spread obeys connectivity more than headlines. This isn't poetry. It's habit formation. Your brain learns to see slopes and flows anywhere, then brings that trained sight back to the sky sharper than before. Give yourself reasons to love the work on days the figures won't behave. A feather that appears exactly where a contour whispered it would months ago is worth a week of debugging. A spin bias that lines up along a corridor is worth a reviewer's snide line. A student who draws their first caustics by hand and gets the funnels right is worth a grant you didn't win. These are not consolations. They are the exact payments a field like this offers. End arguments with invitations. When someone shows you a heroic mural drenched in glow, don't sneer. Ask for their arrows, offer your borders with drift bands and tails and spins and ghost light, and invite them to poke. If they can move your separatrix with a plausible H0, a rung tweak, or a better underdust catalog, pay them with co-authorship and gratitude. If they can't, offer them a patch to adopt. The quilt grows by handoffs, not press releases. Hold one private rule like a compass. Name nothing you can't defend with a gradient. A pass is where allegiance flips in a reconstruction that survives being kicked. A crown is where arrows splay. A city is where hot breath rules and potential wells lie. A wall is where compression lives. If a bright knot sits on a pass and tempts you to call it a city, make the wind shame you out of it. If a famous label wants to swallow your ridge, show the phase space that refuses. Language should report, not seduce. When you run out of energy for manifestos, go back to a small rectangle. Homogenize distances. Bracket H0. Reconstruct with priors that prefer boredom to lies. Abuse the map until it confesses. Measure wind with HI and jellyfish. Measure spin where the torque should tutor. Hunt a faint feather where your contour curves. Invite two honest enemies to try to move your border. Publish 3 predictions with dates. Tape next week's plan to the wall. It is not glamorous. It is how ceilings become slopes. And when the week ends, step outside with nothing but eyes. The band is still a lane. The quiet gap is still a crown. The fork is still a pass you argued about until the figure admitted it. The city's breath is still a wind you can prove in tails and missing gas on the windward side. Your raft's arrow through the microwave's rest is still a civic speed limit, set by ridges and roofs you've learned to map. You don't need to say any of this out loud. You need to keep doing it. The sky will cooperate when asked the right questions. The right questions start with the same sentence every time. Where are the arrows?